microphone, and please kindly put your camera on. Okay. Oh yeah, and don't forget to put on the virtual background, and thank you for your kind cooperation. Once again, to all participants, I want you all to put your camera on and don't forget to put on the virtual background. Thank you. Okay, maybe we can start now. My name is Brilliant Dimas Akbreza Purwadi, and you can call me Brilliant, and I'm your Master of Ceremony for today. It is my pleasure to welcome you here this morning to the second day of the first International Conference on Artificial Intelligence and Big Data Analytics on Thursday, October 2021 at online Zoom forum. We will start with a prayer. According to pray, begin.
Hello, moderator. Hello, MC.
Okay, pray finish. May our activity run well from start to finish without any obstacle at all and provide tremendous benefits for all. To begin our main session, let me introduce Mrs. Desi Novita, ST, MT, PhD as our first moderator today. She is a member of IEEE. She has PhD degree at Graduate School of Natural Science and Technology from Kanazawa University, Japan in 2014. She joined Physics Department, Faculty of Mathematics and Natural Science at Pajajaran University as lecturer since 2006 and continued to electrical engineering in 2015 until now. She is also a faculty fellow, University Innovation Fellow at Stanford University 2021-2022, and her papers are published internationally and are indexed by Scopus and Google Scholar. Ladies and gentlemen, without further ado, please welcome Mrs. Desi and give her a warm welcome. Mrs. Desi, the time is yours.
Okay, thank you, MC. Ladies and gentlemen, before we start the presentation, and in order to avoid any disturbances during the presentation later, I would like to inform about the rule as follows. First, participant, would you please to mute audio? Second, the audience who want to ask question can write in the chat room by mention name and affiliation. Q&A session in 10 minutes. For participants can ask questions by submitting in the chat room in polite language. No raise hand in Q&A session. The moderator will choose the questioner to be invited to open the microphone and open camera if possible to question. Thank you. The Honorable Yudi Andriana, PhD, Vice Dean of FMIPA Universitas Pajajaran, Associate Professor Norma alias University Technology Malaysia, Professor Adi Wijaya, Rector of Telkom University, Profesor Nur Iriawan, PhD, Institut Teknologi 10 November, Associate Professor Dr. Wan Muhammad Amir, University Sains Malaysia, Associate Professor Ghosh and Kusdanesh, University India. The Honorable Mr. and Madam Speakers, distinguished guests, fellow students, ladies and gentlemen, good morning. Assalamualaikum warahmatullahi wabarakatuh. First of all, let me introduce myself. My name is Desi Novita from Electrical Engineering Department, Pajajaran University. I'll be responsible for moderator this presentation today. I would like to welcome you all to this prestigious, the first international conference on artificial intelligence on big data analytics, organized by Research Center for Artificial Intelligence and Big Data Universitas Pajajaran, sponsored by IEEE Communication Society Indonesian Chapter. In particular, in them of this international conference, breakthrough research of Artificial Intelligence and Big Data for Post-Pandemic Recovery. In this occasion, we shall have outstanding presentation from our prominent presenter who I believe shall enrich our insight and knowledge regarding the theme of this seminar. Before the presentation begins, allow me to introduce the presenter. Our third keynote speaker is Associate Professor Norma Alias from University Teknologi Malaysia. Hello, Prof. Hello, Prof.
Assalamualaikum.
Waalaikumsalam. Good morning.
Good morning. Apa khabar?
Alhamdulillah, baik. Okay, I will read a short biography of Associate Professor Norma Alias. Dr. Norma Alias is serving as an Associate Professor at Department of Mathematical Science, University Teknologi Malaysia. She is also an Associate Research Fellow of Ibnu Sina Institute for Scientific and Industrial Research, UTM, and member of the Task Force of UTM Online Teaching and Learning. She is also a member of the Malaysian Mathematical Sciences Society. Dr. Norma obtained her PhD in Industrial Computing, Parallel Computing in 2004. She has diverse expertise, including mathematical modeling, big data simulation, industrial computing, scientific computing, high-performance computing, grid computing, and software development. Dr. Norma is an active innovator, having earned 2 products patent for intellectual property declaration, won 16 medals in the Product Innovation and Invention Expo. 2 more products for commercialization are to follow. With her extensive experience in innovation and invention, she has been entrusted with offering innovation and creativity course at university level, thereby introducing that the innovation and creativity can be delivered in the form of structured knowledge. She has extensive experience in service-based commercialization activities. Okay, without further ado, I would like to welcome our keynote speaker. She will deliver a presentation entitled Predictive Method of Artificial Intelligence for Big Data Enhanced Decision Making. Ladies and gentlemen, please welcome Associate Professor Norma. The time is yours.
Okay. Assalamualaikum warahmatullahi wabarakatuh to all the participants, and especially to Dr. Desi Novita. Okay. All right. I'm very thank you for inviting me as a keynote speaker at the 2021 IEEE International Conference of Artificial Intelligence and Big Data. Right. So this is a time for us to meet together to discuss about what is the artificial intelligence, and then how we want to integrate with the big data to make a decision making based on developing the predictive method. All right. So you can visit the chat. Okay, you can go to the my PowerPoint. Okay, the selected PowerPoint at the YouTube. Right. So now, okay, let's continue. Okay, this is a University Teknologi Malaysia. Okay, our teams here is Kerana Tuhan Untuk Manusia. Alright, and then the location of University Teknologi Malaysia at the Johor Bahru, the main campus. Alright, the branches at the Kuala Lumpur and Pagoh. Pagoh is a center between Kuala Lumpur and Johor Bahru. Okay, Johor Bahru is a south of Malaysia, near to Singapore. Alright, so the campus experience, okay, working with the UTM for I think more than 27 years. Okay, we deal with many students, international, local, foreigner, and then they are working together. But nowadays, okay, some of them staying in the campus, some of them is a remote, okay, remote student or mobile student. All right, so this is my faculty. There are 3 blocks. Okay, this is a journey to go to my faculty from university, main gates. Okay, there is administration near to the Chancellor building, Okay, there is a 2 block, a research block, and then a lecture block, right? There are a department, okay, physics, chemistry, mathematics, all right, and then also a department of bioscience, right? So now, I love if you can scan the QR code, okay, and then we have a simple survey. Simple survey, you can scan, or you can go to the chat. Okay, I go to the chat. Just click at the chat. Okay. Now we go to the chat and click at the chat. All right, or scan the QR code. Right, so I just want to share with you a simple survey, okay, about the big data, okay, artificial intelligence knowledge, okay, and how we want to make a decision with the two approaches, artificial intelligence using a big data, right? So if I can share with you the link and then the QR code, okay, and then we want to get a feedback, okay, whether you can answer, just write one word. Okay, you can go to the chat and then click at the link, or you can write www.menti.com with the code 21404232. Okay, the easiest is a scan or click at the chat for the link. All right, okay, we're waiting you to get the feedback. All right. Okay, I want to get the feedback. So let's see if I can. Wow, okay, there is some feedback here. Right, so I can share the feedback, okay, after my lecture, right? So let's share feedback, right? So now, let's continue. All right, so let's continue. Okay, I want to share with you content for my lecture today on how to develop a predictive model of the artificial intelligence, all right, to make a decision based on data. Okay, so of course, okay, this is deal with the fourth industrial revolution, and then how the big data enhance decision making, and what's the element of the artificial intelligence would be highlighted. Okay, how to do the classification with the predictive model that we develop, and then the technology challenge, okay, the hardware and software dealing with the making a decision based on data, and then the future trend for the decision making, all right, and some conclusion. All right, so now at the first stage, I want to share with you, okay, the simple approach about the big data. All right, so I think better I play with the this video, right, about the simple data. Okay, what is data actually? What is a data? All right, so if I can share with you the okay, let's I share with you. Stop sharing. Okay. I want to share with you a simple video here, okay, about what is data. Okay, data is just not just an image, not just a number, okay, but there is a collection of data that you get from the questionnaire, okay, maybe you get from the numbers, okay, the numbers, or you transform from the graph to the numbers, all right. So there are so many numbers here, okay, but it's really meaningful when we do the statistic approach or develop a model or do the data analytics, okay, data analytics based on the artificial intelligence approach. So there are so many numbers, okay, and repeated numbers, and how we analyze. One of them, they are using smart PLS, okay, smart PLS. What is a smart PLS? Okay, the smart PLS, okay, is one of the strategy, okay, to put a weighted with the integrated parameters, all right? And then some of you using the images from geoinformation system to detect the location, the changes location, okay, the affected area, okay, for a specific disease or the shopping area at the GIS map. All right. So you can see here there are so many transformation from the images to the data. All right, and then analyze and come again to the process of the visualization. So that is a data. All right. So now, let's we talk about data now. Okay, I'm stop sharing. So I go to my PowerPoint. So let's we talk about what is data. Okay, data is comes many types. Okay, many types, many way. All right, maybe it's depend on the times. Okay, depend on the second. And then maybe minutes and so on. Okay, variety of data. Okay, maybe it's come from the voice, from the image, from the text. Okay, from the visualization and others. So the data can be visualized in 1D and 2D. I'm using a data to visualize the temperature behavior of the brain wave, okay, the component, okay, the some parameters to develop a component, for example, the density, the temperature behavior, all right, and then others, okay, which is related to the features of the component, all right. So when we deal with the fourth industrial revolution, now we are in the fourth industrial revolution, we are dealing with the data. Okay, there is a mechanism to control, to monitor, okay, the process. Okay, for example, in nanotechnology, in artificial intelligence, all right, in the biotechnology, all right, in robotic, for example, we are using Internet of Things, okay, dealing with the internet, data, and the system, all right. So you also, sometimes some factories dealing with the robotic, automation system. And what we want for the next future for 5th industrial revolution is to recycle, to go for this ecosystem, to enhance a good predictive model or good predictive analytics. So there is a transformation nowadays. For example, we are doing a video conferencing, all right? So we are converting from wave to the voice, and then to analyze the voice. And then we also go for the streaming, where people out there can go for the streaming, and then you can see there is a transformation, from the signal to the digital, all right? All right, so you can see here, there is a very drastic transformation, there is a drastic transformation from 2019 to 2020, very drastic. For example, you can see, Facebook here, 2019, there is a 1 million people logged in for every 1 minute. But for 2020, people, log in 1.3 million, for every 1 minute. How about 2021? We are still not end, so the data collection at the middle, of the 2021, that is 1.4 million. So it is very drastic increasing. How about others? For example, WhatsApp. I know you're quite familiar with the WhatsApp. 2019, there are 41.6 million messengers come and go through the box in the 1 minute. How about 2020? 59 million. So maybe because of the COVID-19 pandemic, where the people stay at home, but they want to do the activities, all right? So they deal with the WhatsApp, to send a message, to send the command and information, for example. And for 2021 is a 69 million. It is almost 10 million, just half of the 2021. You can see people now try to avoid from the COVID disease, so they stay at home. They do so many apps and courseware to help their activities. For example, here Netflix, because the young people, they love to go for the Netflix. So you can see here from 2019 there is a 694,444 people watch Netflix for every 1 minute. How about 2020? Is a almost 100,000 increase. How about 2021? It cannot be predicted because there is a 28,000 subscribed Netflix for every 1 minute. So this is how data generate based on the text, based on the image, based on the audio, visualization, and others. All right. So you look at your handphone. How many messages come? And how many times you need to answer back your messages at the WhatsApp, for example, Telegram, or any other social media. So there are we can categorize big data into three categories. But now we can categorize the data into 7 categories, because the data is become huge, terabyte, gigabyte, yottabyte. Right, so we can distribute the data. Before this, we said that the data is just a volume, megabyte, terabyte, petabyte. All right, and then they said data also is come from the variety types. For example, from audio, video, text, sensor, stream, and then others type, image and others. All right, velocity, for example, how the data generated every second, every month, every year. All right, so we can categorize into 3. However, when we go to the nowadays, there are 7 categories, not just a volume, velocity, variety, but the value of the data, how the data can make a decision, how the data can be analyzed using the performance analytics and metrics, evaluation, indicator, right? So visibility means that how the data can pay attention, prominence to the users, to the stakeholder, to the people, machine learners and others, all right? And this viability means that how success the data can be predict as an outcome, all right? How we can develop a predictive model for the viability data. And then veracity data, where some data is very messy, quite messy, but can we trust the data? Can be considered the data is have a high quality and accurate? So it depends on how you analyze the data. How do you analyze the data? There are so many types. You can categorize, you can explain, you can describe the data, unstructured and structured data, labeled and unlabeled data. All right, there are so many ways. For example, the simplest, we said that the numbers, the date, the string, the information, is we call as a structured data or label. We can label it. All right, so it's very easy when we want to do the artificial intelligence strategies based on the machine learning or deep learning. And unstructured data is like images, audio, video, email, spreadsheets, where we need to transform to the labeled data. All right, so we need to we need to do a transformation. We need to do some process with the unstructured data, but there is a way to solve, to analyze this data. All right, so now how mathematics deal with solving the problem, especially in the 4th industrial revolution. And then why I address mathematics, because the root, the fundamental of the artificial intelligence, or sometimes we call as a machine learning, sometimes you call as a deep learning, is from mathematics background and the statistic background, right? So there are so many ways to do, because mathematics is colorful of the algorithm. We can choose one, all right? Even though there is a software to support the artificial intelligence process. For example, here, there is the changes carrier nowadays, especially for people have a background in mathematics, because they are going to be, for example, data analysts and data scientists. So you can see that there is a transformation also in mathematics. The way they are thinking, the way they act, the way they perform, the result, and so on. Before this, we are very focused on the pure maths. But now, now mathematics also do one transition we call as a mathematics literature. all right, where this is always deal with the everyday activities, okay, with the carriers. For example, okay, you can see I love to address in 14 September 2021, Lisa Daly said that what is people looking now is an internet of small satellite, meaning that there are so up there at the satellite area, there are so many satellites. Now they want to communicate between satellite and satellite. That is stage. Not just communicate through handphone, not just communicate through the email, through the social media, but now people looking for developing the internet of the small satellite. So that we call as a data constellation. We develop a data constellation. All right. So now, why mathematics? Why statistics as a root of the artificial intelligence and machine learning? Because mathematics can transform from the real problem, all right, real problem to the mathematics problem, and then we can develop the model, we can develop the equation and graph based on the theorem definition corollaries, which is we call as an axiomatic thinking, to get the prediction and do the assumption of get the solution for the real problem. So that is in mathematics. However, the weaknesses of this, we don't have AI, artificial intelligence element. We just do the modeling. We just do the simulation. Right. So now the mathematical people start thinking how to make the the data what we have to be more intelligent. So that's why they start do the imagining, expressing, do a specification from the generalization, all right, and then they start to develop the encountering mathematical things. For example, they try to distribute or differentiate between the explicit or implicit problem, all right, the freedom and the constraint. All right. Of course, the intention now we want to be more holding whole. Meaning that we want to discretize the problem, and then towards the end there is we try to get a pattern. We want to find the recognition of the relationship between the parameters. That's how the mathematical thinking. So based on this one, so we can do some solution, some assumption, some understanding, between our side, and then their data from their side, and then the truth using the artificial intelligence. All right. So now, how big data enhance decision making? That is a big question that we want to answer. All right. That is actually the future. The future of career now is too much beyond of what we thinking. The future who people are doing the decision making we call as a data analyst or data scientist. Because they are dealing with the data, all right, and then they are dealing with the mathematical modeling, statistics, and algorithm. All right, they know the data communication. All right, they also know how to analyze the data using the machine learning, statistics. At the first stage, they are doing the mathematical modeling for the maybe they want to do the classification, or categorization and others. And then, of course, towards the end, they do the predictive analytics based on the knowledge discovery, from the data, So now, for the decision making nowadays in fourth industrial revolution, we believe that, mathematics is one of the fundamental, bring together with the technology, all right, that's we call as a develop a data engineering, where I told you already, that's come maybe from the satellite, from the sensors, from the questionnaire, from the data generated from the meters, and others parameters that you do, okay, to do the data collection. All right, and then towards the end we do the data sciences. Okay, in this case we are using AI, okay, machine learning and deep learning to make a decision, to support, okay, any application, for example, industry, in business, in manufacturing, okay, in research and others. All right. So now, okay, as we know, the data generate very fast, okay, for every 60 seconds or 1 minute, okay. So you can see, okay, the cloud, okay, full of data. For example, you are lecturers, I'm also lecturers. We always, okay, dealing with the educational 4.0, all right. Okay, before this we do a face-to-face, but now, okay, we are dealing with the education 4.0. All right, so there is a transition nowadays, okay, from the small data, okay, for example, if you deal with the programming, okay, you always, okay, know how to transform a problem in the programming, in the procedure. Maybe you are using C, maybe you're using MATLAB, Mathematica, all right, C++, Visual, Basic, Java, and others. That's a simple data. It's very small. It's only gigabyte or megabyte, all right? However, when we start looking for the big problem, grand challenge application that deal with the big data. So now the model is become complex. It's a multi-model involved, all right? Not just ODE and PDE, okay? Not just ordinary differential equation or partial differential equation. It's beyond than that, because the data is come from the sensor, the device, the images, okay? The grid generation, okay? Not just one-dimensional problem, okay? Not just two-dimensional problem like MRI images, one-dimensional problem like a wave, elliptic equation, okay, linear line, all right? It's more than that, all right? It's more than that. So in this case, okay, there is a transition, okay, from using C programming, but now you need to integrate with the PVM, for example. Okay, before this, we are using, okay, Fortran, for example. So now you can integrate, okay, with the what we call communication protocol, for example, MPI. So what is impact? The impact is a very, very impressive, because then you can get an accurate prediction, you can get real-time observation, real forecast, developing a time series forecast, okay, and then the result is very precise, okay, the residual, the error will be reduced. And then, of course, when you develop the 3D, okay, the result is a very good visualization, a very good visualization. So now there is an effort, okay. That's why I just send you the first survey, okay, how the challenge for applying the artificial intelligence, okay. So this is what we call as a artificial intelligence information technology for fourth industrial revolution, which is integrated between the intelligent knowledge, okay, from the machine learning, deep learning, okay, statistical approach, all right, and then mathematical modeling, and then plus the big data, okay, come from the Internet of Things cloud, okay, or maybe from the smart city, or around you, you have how many devices around you, okay, not just handphone, iPad, laptop, sensors, okay, body sensors, wearables that you wear almost every day, that will create a big data. And then, okay, now people looking for the new terminology. Okay, what is that? Blockchain, okay, where the data can be blocked, okay, integrated. And I just mentioned just now is data is based on the constellation, all right? Okay, people now looking for the Bitcoin, okay, one of the strategies, one of their approach from the blockchain, okay? All right, so now, when we go for the fourth industrial revolution, okay, for my area, okay, I'm really focused in this circle color, okay, red color, all right? I'm focused on the specification, modeling, and analysis based on the big data analytics, okay? I'm also doing the heterogeneous model, which is more complex nowadays. I need to learn about network between the data, between the device, between the satellite, all right? And then times synchronization, okay? In this case, people always said that this basic one is a time series, okay? Time, okay, the basic more than that is a time step, okay? So I'm developing the model based on the time and space, okay, to make sure the model for the computational is be predicted, continuous and discrete. Okay, discrete because there is a digital transformation, all right, from the images and others. Okay, you can see here the latest research topic 2021. There are so many. Okay, there are so many, all dealing with the social network nowadays. Okay, because there is an infodemic happen. Okay, viral social media. So people looking the artificial intelligence to describe, to categorize, to cluster the problem, okay, in terms of the economic approach, for example, all right, the social media, okay, viral, okay, for example, infodemic problem, all right, and then the world economic, okay, the world economic nowadays, okay, all, okay, we solve using the artificial intelligence. Okay, the simple case, okay, if you have a company, all right, during the pandemic, from February 2020, 2021, all right, our profit may be reduced up to 20% to 80%. It depends on the types of company. So how we want to create a new business, how we want to create a new customer, how we want to make sure the business, okay, can fulfill the future needs, okay, the future needs. So that's we can analyze from the data, all right? So now let's go, okay, for the others example. You are lecturers, okay? I'm also lecturers, okay? We deal with the fourth in the education 4.0. What is a fourth? What is a industrial? What is education 4.0? There we deal with the future ready education in UTM. Okay, so people, okay, student and the lecturers, okay, all the technician dealing with the electronic side, okay, database, software, digital platform, electronic technology and academic, okay, and academic try to reduce the misconduct when we do the online teaching and learning, when we do the synchronized and asynchronized. So that's we deal. Okay, how? Okay, we deal with the of course. Okay, we deal with the video conferencing. Okay, when we deal with the video conferencing, we need to check the network. Okay, whether the network is a low, okay, medium or fast. So this is start, you collect a data, you check a network first, all right? So there is a network, okay, to do, okay, the other process in collecting data in Educator 4.0, software, apps, tool, and then courseware, right? So I know you're quite familiar with the Zoom, you quite familiar with the learning management system. I know you also quite familiar with the tool when you want to do data collection. I just use Mentimeter just now. So I start collecting data, all right? So from the data collection, okay, you can get something, okay, from your audience, okay, from the audience. And then, of course, okay, you're quite familiar, okay, collecting data and then develop a video, okay, to your customers, okay, to your student, and how to provoke the ideas, all right? So in Education 4.0, I know there are so many tools, okay, I'm also, okay, address here, okay, and then there is a problem. And also when we want to get a data, we want to analyze the data from the software, for example, Flipgrid, okay, I'm using Padlet, okay, I'm quite familiar with the Nearpod, I'm also proposed, so the data can be analyzed using many tools. Okay, the simplest is using Excel. The simplest is using SPSS. The simplest is a smart KPLS or PLS. Or if you have a big data, you can go to the artificial intelligence. All right, so now, how, okay, we want to combine our knowledge on the mathematics, artificial intelligence, how to do the big data analytics, okay, how to analyze the data, okay, and then to solve a problem, and towards the end, to make a decision, all right? So if you are lecturers, you are a researcher, you how to make a good paper, okay, good paper from the outcome of your research, all right? So now, we not just okay to use a data to answer a question, how many, what, okay, and then what is the numerical values, okay, of the data. So this is a very basic, okay, because for the pioneer, we said that data, okay, can be categorized into quantitative and qualitative. All right, so that's why many approach, okay, in mathematics can solve all the quantitative and qualitative data, all right? So in my case, okay, I'm not just develop a mathematical model because mathematical modeling has a weaknesses. I know there is a strength, but the weaknesses is the parameters. Okay, for example, the temperature behavior in our body, temperature behavior in the room. Okay, the chemical reaction. Okay, for chemical. For the chemical reaction in our body, for example. All right. So I need to go something. Okay, I need to make something. Okay, which is more predictive, more accurate. Okay, more precise. So I need to get a data, okay, from the real, okay, maybe from the images, from the sensors and others. And then in terms of that, okay, I know where, when it's begin and when it's end, and how much data I need, okay, to get a good decision making, to get a good prediction. I know, okay, to do that, okay, there is thinking involved here, okay. For example, okay, getting data, okay, I need to have some expert in terms of the computer and device, okay. I know I need to learn how to do a coding, okay, because the AI need the coding, whether software from open source or licensing, all right. I need also know the digital literacy, not just a read, not just do a coding. I need to know the network, the communication, okay, the bandwidth, all right, and develop a critical thinking, because when we analyze the data, there are so many effort on the critical thinking because the data is a messy, cannot be trusted, okay, if you can distribute the data or different pixel. If you deal with the images from different data bank is different pixel, so cannot be comparative in others. So how to solve this problem? All right. So in mathematical modeling, okay, you develop a model from the axiom, from the definition, from the colorist, from the formula. All right. So you believe on that. Okay, you believe on that. All right. But however, okay, when the data is become huge, okay, you generate a data, for example, using ODE, PDE, the data become huge because there are so many specific area, for example. All right. So when you have a big data, how to do a simulation? So in this case, we go to the high performance computing system where they require you to do the parallel computing. Okay, in this case, okay, the important is how you distribute the data, because the data is a terabyte. So one CPU cannot solve a terabyte, okay, data simulation or yottabyte. Okay, all right. So one CPU cannot. The CPU will hang because they go to the cache memory. So in this case, okay, you need to distribute the data to a number of processor, all right, to a number of processor. So in this case, okay, you need to have some knowledge on the data distribution. All right, so now, okay, this is the scenario, okay, in my research, okay, why I do a transformation from the doing mathematical modeling, okay, statistical approach to the AI, artificial intelligence. Why? Because the source, okay, the data source is a very drastic, okay, generating, okay, the data for almost every second, every minute, every hours, every days, every months, and every years. So it's come from the smart grid that I'm using now, okay, smart sensor that I'm using, okay, medical equipment, for example, images from MRI, all right, digital camera, okay, because digital camera give you images every second, right? So because of when we did nanotechnology, all right, the data is very fine, all right. So for example, images from the microscope, okay, the light microscope, for example, FEM, SEM images, okay, the size is nano, 10 power negative 9, all right. So in this case, I need to analyze the data, whether the data is structured or unstructured. Okay, I need to convert from the unstructured to structured, from unlabeled to labeled. All right, and then I need to know the amount, okay, of the data, the volume of the data, how the data generate, the velocity of data, variety, and then visibility, and others 7V. All right. And then towards the end, if the data is small, it's no problem. for me to do the extension version, whether I want to do the numerical method and simulation, all right, and then statistical approach, okay, using the forecasting, for example, and then HPC problem, okay, HPC, okay, means that I need the platform to support my data, whether I need to use high performance computing system to support the big data simulation, or just using one laptop or one computer, all right? So now, the important here, the important here, the strengthness of the artificial intelligence is the strong background on the theorem, okay, in the theory of the mathematical modeling approach, all right? So now, okay, in statistics, okay, people always do forecasting, stochastic, deterministic, all right? And then in mathematics, okay, we always deal with the continuous time, discretized, okay, time steps, time series, time dependence, all right? So we always deal with the dynamic, okay, dynamic system, okay? Nowadays, it is not it's difficult to find a static okay, static system, okay, which is static means that the system is a description at the one point in a time. All right, now people, okay, for example, temperature behavior in this room is a dynamic. Okay, sometimes, okay, there is an effect from the aircon, sometimes the weather outside, okay, sometimes the boundary condition of the wall and others. So this is a model category that we need to think, okay, when we have a problem. All right, so now I go for the simple, okay, simple example, okay. Now we are in new norm pandemic COVID-19, all right. We already pre-COVID in 2020, all right. So now we are collecting a data, all right. Okay, I send, okay, I visual here the active cases of COVID-19 for the selected successful country, for example, in America, okay, in Russia, in China, in United Kingdom, and in Singapore. You can see, okay, the active cases is reducing. Okay, started from, for example, in America from April 2021. All right, for Russia is May 2021, and then China very early April 2020. Come on. And then United, okay, it's May 2021, and Singapore, okay, reducing the data started from October 2020. All right. So what happened to my country? Okay, the wave is now, I think, 4 or 5 wave. Okay, it's not reducing, but sometimes increasing. So I need, okay, to find what happened to my country. Okay, whether the active cases, the death, the recovery from the COVID-19 reducing or increasing. So in this case, I need to apply artificial intelligence to analyze this data. Okay, even though the data is not big, okay, because, okay, in Malaysia, the COVID-19 started from 2020 and January 2020. All right, so we can collect the data, okay, in terms of the numbers, okay, we can create a wave, okay, and predict, okay. All right, so based on this machine learning, okay, this is automatically learners, okay, automatically training to improve the decision making. So means that, okay, we have a data from January 2020, we keep, okay, increase, okay, the data till now, 28 October 2021. All right, so means that around 900 days, okay. All right, so the data will produce, okay, the prediction, okay, what happened for the next month, for the next week. All right, so this is a machine. It's like a machine where the machine collect the data and then analyze the data using some approach we call as a machine learning or deep learning. All right, so now what's different between big data and one of the element artificial we call as a machine learning? All right, so I just want to say that big data is provide a variety of data or the velocity of data. Machine learning is a technology, okay, to do a data driven, okay, they do a learning and they do a testing of the data, all right, to make a decision. All right, so now how about the pattern recognition of the big data? big data, okay, there is a reverse some pattern through the classification and sequence analysis, okay, because we have a data, we can do a classification, we can see a pattern of the COVID-19 in Malaysia, for example. How about machine learning? Machine learning, okay, is a concept, okay, is a knowledge, is a methodology, okay, using a big data, okay, and learn the data and okay predict what happened to the data, all right, to the what is the pattern or design of the data. All right, how about the data volume? Big data, of course, okay, large scale volume. How about machine learning? Machine learning is a okay, we do the overfitting, okay, or we call as a fit the method to the specific data. All right. Sometimes, okay, the weaknesses of machine learning is overfit, okay, over prediction. All right. So now the purpose of the big data is to okay, we collect the data, we store the large data, all right, and then we want to find a pattern. How about machine learning? Machine learning is what we call okay as a methodology to train, okay, to predict, okay, and then to observe, to monitor for the future prediction, future okay decision making, right? So I'm always deal with the classification, okay, one of the element, okay, when I do the machine learning algorithm, all right. Some of you can use a regression, okay, regression, you want to see the data, okay, whether in how many slope, okay, huge slope, huge gradient, low gradient, and others, all right. And then clustering, okay, they can also use the cluster the data, right, cluster the data. So in this case, okay, I need to have some tool. Okay, I can categorize. The first is the application. All right, what is the application that I want to analyze? All right, so people always say that I'm multidisciplinary people. Yes, because okay, we have a data many types. Maybe from the okay speech. Okay, maybe from the data from market segmentation. All right, and then language processing, for example, when you have a natural language, okay, you can do a processing, all right? So many applications, okay. In my research, I'm using, okay, how the COVID-19, okay, virus infected to the lung, okay, how the amount of glass, okay, ground of the lung, okay, so from the images, okay, MRI images, okay, I can predict what stage of the COVID-19, okay, disease, okay, for a specific patient. All right. The second is I need to, okay, choose whether the types of artificial intelligence, whether machine learning or deep learning. So I'm always use machine learning because the data sometimes is not too huge. Okay, if the data huge, we can transform to the deep learning. Right. So the deep learning, there are so many approach. For example, you can use okay ANN, streaming, okay, extreme learning, and others. All right. The hardware. The hardware, for example, okay, since the data is small, you can use your own CPU. Okay, student can use their own laptop. If they are using a big data, they can telnet the high performance computing system at my lab. Okay, I'm using GPU, CPU architecture. I'm using shared memory architecture and distributed memory architecture. And then the software.
Professor, yes? Time is up.
All right, so
maybe yeah,
I can close. Okay.
Okay.
All right, I can close. All right, so give me 5 minutes, Ken.
Okay.
All right, so the other one tool to do the okay dealing with the big data and machine learning is a software and Python. Okay, software, for example, I'm using Python because it's open source. All right, so now, so this is about the data. Okay, so I want to go. You can go to my slide. All right, so. All right, so what is the result? Okay, what is the result? The result shows here, okay, when I use okay, data from government of Malaysia on the COVID-19, I can predict, the red color is, I can predict based on the, we call as a convolutional neural network. Okay, I can predict what happened to the COVID-19, the active cases, okay, for next month from July 2021, August 2021. I get the data from January 2020. So this is a very good compared to the model, for example, SIR model. Okay, the model is just to give you a pattern, but here is a really exact solution. All right. So when we do the forecast, you can see here, all right, the artificial intelligence can give you a serial. Okay, what happened to data? The what we call a seasonal pattern. All right. The season pattern is the frequency is similar. All right. The train data, okay, the train data is similar to the actual, the original data, and then the residual, the error for every month you can find, okay, drastically accurate. All right, so now, okay, what is the journey? Okay, journey is to do a data analysis. Okay, you need to know mathematics, statistics, okay, some programming, all right, and how to handle the data, okay, and then machine learning, okay, if the data huge, we go to the deep learning, okay, data visualization, and then towards the end, there is a control process, meaning that you need to develop the software, okay, the version, okay, increasing version because of the increasing data, all right. So now, as a conclusion, okay, I just go to the conclusion, okay. All right, okay, let's we go to the conclusion, all right. As a conclusion, we can say that, okay, to interpret the data, we need to make sure the data is trustless, okay. When we collect the data, we process the data, we differentiate the data should be trustless to make a good hypothesis. Second, all right, the 7V, for example, velocity, the messy of data is make sure, okay, it's become the model complex, okay. So we need to scope, put a range when we do a data analytics solution, all right. And then prediction model, okay, that we do based on the classification method, for example, okay, ANN, artificial intelligence, deep learning, abstract learning, all right, support vector machine and others, okay, with the specific classifier method. You should, okay, could be a revolutionized data analytics, database and enterprise IT, all right. So the variable of data, low cost community hardware, new information management, data analysis software can produce a unique innovation, can produce a good, okay, accurate decision making. All right. So we believe that the multidisciplinary integrated from the fundamental mathematics, statistics, artificial intelligence, big data, okay, produce more educated, okay, educate, means that is trained, okay, the process of making decision, okay, especially when you do the research, development, and the commercialization of your outcome, right? So before that, okay, I love to get what is the feedback, okay. I'm stop streaming from the survey that I, okay, do the, okay, background just now, okay. So come on, if I can get the, okay, update, okay, of the survey. So I'm sharing you the survey here, right? So the result shows that, okay, people said that limited knowledge, people said that it's very complex data, all right, dealing with the deep learning, all right, so means that you need to know, okay, some classifier method, some, okay, machine learning method, all right, and then the budget, maybe budget because of deal with the high performance computing system or parallel computing system where you need the GPU, CPU, or you need multi-core system with the huge memory architecture. Computer resources, yes, for example, okay, most of the software is a licensing, but you choose the open source, for example, Scilab, okay, TensorFlow, Python, all right, and Spider, okay, integrate with the MATLAB and others. And then the not widely used, okay, not widely used Okay, but now, okay, we are in the COVID-19. Most of my researcher, my student, my PhD student, okay, they can go, okay, they can go prolong, okay, they can continue their research even though they work from home, because we are data oriented, developing algorithm and solving the analysis, okay, of the big data analytics. And then the other one is a big data. All right. So maybe big data you can get from the data bank. Okay, we need to collaborate for other organization to get a big data, because big data can produce a good result, accurate result. All right. So thank you very much. I send my session to the respective chair, Dr. Desi Novita. All right. Thank you.
Okay, thank you, Associate Professor Dr. Norma. Thank you very much for their informative and interesting talk. And let's give once again a big round of applause for Associate Professor Norma. Okay, very well, ladies and gentlemen. Now we come to the question and answer session. Please, okay, I read the chat room from Muhammad. Sorry, this is what are the strategies in completing the big data if we don't have a computer with a high performance?
All right. Okay. I share with you my journey. Okay. I share with you my experience,
Yes.
my journey. All right. So if I can share with
if
you.
we don't have a computer with a high performance computing class.
Yes. All right. Okay. Before this, we are using one CPU, one computer, because the data is limited. It's only gigabyte, it's maybe megabyte, okay, kilobyte. So you can use one CPU. All right. So, however, when we deal with the terabyte, all right, yottabyte, all right, and then, for example, trillion, okay, trillion data. All right. So we cannot, okay, we cannot use one CPU. They cannot afford big data simulation, high performance, okay, computing able to do that. Okay, the simplest way we merge what I'm doing, okay, during my PhD in 1919. Okay, so I merge the CPU. All right, now we can replace with the quad core or GPU CPU. All right. Now people looking the new one is okay. For example, for the big data, for the high performance computing, okay, they using GPU CPU, graphic processing unit, and integrate with the GPU, computer processing unit. All right. So this is what we do now. All right. What we do now. So if you can have okay, deal with the Fugaku supercomputer, okay, where they feel they can adapt a big cloud, okay, for the big data, all right? So you can use this processor, okay, to process big data simulation, all right? So for example, when you convert the images, okay, into a digital, so you need a huge that you create or you generate a huge data. That's why if you deal with the okay, maybe gigabyte, okay, maybe kilobyte, okay, you can go for the one CPU, one laptop. But if you deal with the 450 quadrillion, not just trillion, quadrillion, okay, means that 10 power 16, okay, more than 10 power 16, okay, computational. So means that you need to have a supercomputing, high performing computing system. All right.
Okay, thank you, Professor Norma. The challenge of artificial intelligence in our research about AI to application in robotics. So the challenge how to make this in real time. So to get in sensor, so we need the sensor. Also, we use the IoT. So the problem how to make in computing, we get the result in computing, but for the real time, it's a challenge in communication, in IoT and sensor. Thank you, Mr.
All right.
Thank you, Prof. Norma. Okay, once again, thank you very much for Associate Professor Norma for this informative and interesting talk. Nice to meet you. We hope that we will make the collaboration, internship, and yes, the other collaboration. Okay, today, next certificate session for keynote speaker. I'm going to return this session for MC. Please, MC.
Okay, thank you, Mrs. Desi Novita. Next, we are going to have a certificate of appreciation presentation, and which will be presented by me as your master of ceremony of today's event to the keynote speaker. I would like to invite our first speaker, Associate Professor Norma Alias of University Technology Malaysia, to join me here. And I think the it's already spotlighted. So for the documentation team, you may lead the photo session. Excuse me, documentation team. And for the operator, can you please share screen the certificate? Okay. Okay. And now, for the documentation team, you may lead the documentation session. Okay, I think that's all from the documentation team. Once again, I would like to thank you to Dr. Norma Alias, and back to you, Mrs. Desi.
Okay, MC, Mr. Brian. Thank you, Associate Professor Norma. See you next time, next seminar or international conference, or maybe you can come to our university in Pajajaran University. Thank you. Okay, now, ladies and gentlemen, let's welcome our second presenter. Our second presenter is Professor Adi Wijaya, Rector of Telkom University. Hello, Professor Adi Wijaya. Nice to meet you.
Nice to meet you. Dr. Norma, Masya Allah. Assalamualaikum. Nice to see you again. Nice to see you again.
Okay,
you
Professor
will
Adi
come
Wijaya.
to Bandung.
I will come.
Okay. I still remember Mi Bandung in KL, yes, right? In Johor.
Welcome to Malaysia. Welcome to Malaysia.
Inshallah,
Welcome to Johor.
Inshallah.
Okay, thank you. Yes, Professor Adi Wijaya, I will read your short biography. Professor Adi Wijaya is Rector of Telkom University, Program Studi Home-based in School of Computing. His educational qualifications are as follows. In 1999, he attained his bachelor degree from Mathematics Bandung Institute Technology. In 2004, he got his master degree from Mathematics Bandung Institute Technology. In 2012, he attained his doctor degree from Mathematics Bandung Institute Technology. Research interest in graph theory and its application, combinational optimization on image processing and data mining, data science, so many papers, publication, international journal, conference, indexed by Scopus, Google Scholar, and ETH. Professor Adi Wijaya, also I got the reviewer, International Journal on Advanced Media and Communication. In August 2019, Professor Adi Wijaya led Telkom University to become the best private university in Indonesia, according to the Ministry of Research, Technology, and Higher Education. And with the achievement, Man Obsession Magazine Award. Wow, Professor Dr. Wijaya as Inspirational Counselor 2019. Oh, it's okay, inspirational. Now, ladies and gentlemen, let's welcome our second presenter, Professor Adi Wijaya, presentation entitled A Survey Cancer Classification Based on Microarray Data. Ladies and gentlemen, please welcome Professor Adi Wijaya. The time is yours.
Thank you, Dr. Desi. Let me share screen.
Okay.
Okay. I'm looking for the slide for today because many slides here. Icaibda, right?
Not yet. Not yet.
This event. Okay. Okay, search message. I forgot the name of file. Okay, Adi Wijaya. My desktop. Okay, you can see the slide.
Yes, clearly.
Okay.
Please slide show, Prof.
Okay, thank you. Okay, thank you very much, Ibu Dr. Desi. First of all, Assalamualaikum warahmatullahi wabarakatuh, and very good morning for ladies and gentlemen. Thank you for inviting me in International Conference Artificial Intelligence and Big Data Analytics, ICAIBDA, from UNPAD. And thanks the committee for inviting me, for opportunity. And then before I start my speech, let us praise and gratitude to Almighty God because His blessing we can attend here in this event in healthy condition in the middle of COVID-19 pandemic. I am very pleased to be able to give speech a speech for the International Conference of Artificial Intelligence and Big Data Analytics 2021. Oh yeah, today is Hari Sumpah Pemuda, right? I remember that the first president Republik Indonesia, Soekarno, said, "Give me 1,000 old men. I will undoubtedly rip Semeru from its root, and give me 10 youth. I will undoubtedly shake the world." Selamat Hari Sumpah Pemuda for all of us, and keep up the spirit to give the best contribution for our country and the world. Okay, yes. back to the laptop. Today, I would like to present a part of my research in Telkom University with title is a survey cancer classification based on microarray data. Okay, this is outline of my speech. First of all, in the background, I would like to explain why this research is important and what kind of data will be used in this research. And then after describing the objective and methodology, I would like to explain the survey result from some articles and papers which is related with microarray data classification or cancer detection. Before I finish my speech, I will give a comparison from my preliminary research about the results of classification in microarray data classification, of course. Okay, in the background, cancer is the largest cause of death worldwide. This deadly disease could attack everyone, either children or adults, but generally it attacks people with age over 40 or above. 40 or above. This disease attack is every part of human bodies. I think we know that from the International Agency for Research on Cancer, or on 2018, the number of cancer sufferers has rise up to 18.1 billion sufferers with 9.6 million mortalities. Globally, around 1 in 6 death is caused by cancer. It's I think this is important for us to remember this information, and then hopefully all of us are doing well and avoided cancer in our life. Cancer is divided into several types. Some of them which attack most are lung cancer or breast cancer. In 2018, lung and breast cancer attacks more than 2 million people for each type. This deadly disease is important to detect. Is important to be detected early, so the patient could get the right treatment for the cancer. There are some methods to detect cancer. They are USG, ultrasonography, blood test, pap smear, endoscopy, or gene expression. About gene expression is Dr. Mina Kumari from Johnson Cancer Research Center explain about this. In the medical field, researchers are now attempting to use new technology known as DNA microarray. Microarray is something like biochip, which hold 102,000 of genes in the form of DNA. This is collection of microscopic DNA, sport attached to a solid surface, and scientists use DNA microarray to measure the expression level of large number of genes simultaneously, or genotype multiple regions of genome. A DNA microarray could be used as a cancer detector via analysis of gene expression. Gene expression, of course, affected by cancer. This analysis of gene expression use two types of DNA. The normal one is attacked by cancer, and the another one is the normal. Furthermore, Ranja Sharma in 2016 said that each DNA will also emit different colors based on the color it is signed. Microarray data has huge dimensional, usually called as attribute or feature in the data. This problem affect the performance of computational time of the system we can build. Therefore, dimensional reduction must be applied before the classification process. The process will reduce computational time and increase the performance of system classification. As well known, there are several methods that can be used to perform dimensional reduction. Ladies and gentlemen, the cancer, we know that many types of cancer. In this research, I use data set from Cambridge repository. The data set that will be used here consists of colon cancer, lung cancer, leukemia, and ovarian cancer. The tail of data set shown in the table. Records is indicate the number of individuals observed. Meanwhile, the features indicate information about gene expression of each record of each individual observed. Microarray data has a much higher number of features compared to the record. Therefore, dimensional reduction using feature selection or feature extraction is necessary. Is the cancer data, its cancer data only have to class cancer or no cancer. This is to class cancer or no cancer, and we can see the number of feature is very high, very huge, from 2000 until more than 15,000 feature. And then the objective of my speech is how build a cancer detection system that only has a high accuracy, but also has low computational time. Hopefully, we would make collaboration with all participants to make a research in this field. A methodology. I would like to explain about the generally methodology in this research. In this slide, step by step, how we are doing this research is provided in the flowchart, and then the overview of the system consists pre-processing of data set. Usually we can doing the normalization or something like that, and in the reduction dimension step, we can use feature selection, and then or feature extraction, and then splitting data set to the testing data set and training data set, and then we build a model of classifier, and then we can use AI or machine learning or something like that, and then we can test the testing data set to classify the supervised data, cancer or no cancer. In the data processing, the feature is data set had wide range value, which could affect the performance of system. As I mentioned before, the normalization will be applied to each data set, so that value each feature of data will be around 0 to 1. And how about the reduction dimension? Dimension of pre-processed data set, which will be reduced using feature selection or feature extraction, and some method will be explained later in the survey paper. And then the point in this step, how to reduce redundancy features. How about the splitting data set? In this process, the data with smaller dimension from feature selection or feature extraction before will be divided into training data and testing data, and the training data will be used to build a classifier model of the system. And while testing that was used to the test system, the testing data will be used for the testing system. And furthermore, the ratio training data and testing usually 80% for training and 20% for testing. And then how the classifier constructed? I think everybody knows that by training data we can find the optimal parameter for the classifier, and then model will be able to obtain the model which was obtained by optimal parameter can be called the classifier model. And then what next after we have the classifier model. In the next step, the classification process, which aim to the test the classifier that has been built before. This process was using testing data, and of course, in the next after the classification process will be evaluated. The evaluation can use something like to get the accuracy, can use the F1 measure or confusion matrix or something like that. And then, okay, this one about the survey paper, what I mentioned before, that in this, the first one, Bisan and Bisan Gather, and this one is IBM researcher, published in European Journal of Operational Research. In this article, he explained how to find limited number of genes that highly differentiated among the classes. The method, an approach based on iteratively adjusting on-bound L1 norm of the classifier SPM. We know, okay, L1 norm, it means the sum of magnitude of the vector in the space. I think it's so mathematically, and then I will go to the number, the second one. The second one is Ma'ruf and me at 2018 use the MRMR as feature selection and SPM as classifier. The system performs is good. I mean, the F1 score achieve more than 80%. This research also compared the result of the system with dimension reduction and without it. Furthermore, the system without dimension reduction, the F1 score is below that, about 72%. This research concluded feature selection are selected from the dimension reduction process, have better generalization and represent the characteristic of the class field. And then the third one, Sukla et al. In 2019 proposed the new method called ensemble multi-population adaptive genetic algorithm, EMPAGA. This one is ensemble method, and then this method consists of two-phase ensemble gene selection to filter noisy and redundant gene, and adaptive genetic algorithm based on multi-population strategy with SPM and naive Bayes classifier as fitness function. The result of EMPAGA is ensemble multi-population adaptive and genetic algorithm is compared to multi-population adaptive genetic algorithm and the original of genetic algorithm. This research concluded that the proposed method is better than others. And then the last one in the fourth is Sahizan Othman et al. Give the research result and published in IEEE Access 2020, describe how to improve the Kuko search algorithm. The method in this approach, hybrid multi-objective Kuko search, with evolutionary operator. He explained that their open problem to enhance the parameter tuning of Kuko search in the future research. I think it can be used in this problem. And then Ali Daba et al. In expert system and application. provide a problem how to apply mode flame optimization algorithm or MFOA based on a gene selection and classification of DNA microarray data. He proposed a new extension of MFOA that called mutual information maximization modified mode flame algorithm. The experiment results, which has been conducted on 16 benchmark dataset, either binary class or multi-class, confirm that the proposed method, which proposed by Ali Daba et al., provides a greater classification accuracy. Also, they give future research to extend algorithm to address other issue. I think it can be used in this problem. And Alok Kumar Sukla in 2020 in computational intelligence, he explained how to select discriminative biomarkers by using distributed feature selection method to overcome high dimensional data or high dimensionality or overfitting issue. He developed new gene selection technique by combining minimum redundancy, maximum relevant (MRMR) and teaching learning-based optimization for accurate cancer prediction. This combination, teaching learning-based optimization with MRMR. Precise teaching learning-based optimization with opposition-based learning approach further refines to reduce feature selection, to reduce feature set, then can contribute to identifying the type of cancer. The distributed filter in feature selection, which involve the several filter method that are applied to partition of data, combined after that into unique feature ranking to estimate the performance of system. And then the number 7, Ge Zhang in the Journal of Interdisciplinary Science, Computational Life Science, 2020, provide an explanation how to overcome to disadvantage of filter approach. They give hybrid based on information gain and MBKH algorithm to obtain the best feature subset. By this research, they give suggestion to integrate the filter algorithm such as Markov blanket or t-test into wrapper algorithm. And then the last one, Serhat Kilichar-Salam et al. Conduct a research to build a cancer detection system using a hybrid method. This method combines relief and stacked autoencoder SAA as a dimension reduction and SPM and CNN as a classifier. The dataset used in this research are ovarian cancer, leukemia, and central nervous system dataset. Furthermore, the result of proposed method are compared with the result of naive Bayes, KNN, random forest, rotation forest, and original SPM classifier. This research conclude that relief and CNN gave the highest accuracy, with the average accuracy about 94%, more than 94%. And then it's our previous work about the cancer detection based on microarray data classification. In 2018, my team write articles in Journal Information Processing System in Korea. In this article, we use K-mean algorithm as the clustering approach to the feature selection to get the same characteristic feature in one cluster, so that redundancy in microarray data can be removed. The result of clustering is ranked using relief algorithm, such that the best scoring element for each cluster is obtained. All base elements for each cluster are selected and used as feature in the classification process. The accuracy of the proposed approach, the classifier using a random forest, and then we can say that the accuracy combine the clustering and random forest classification has higher accuracy. I will explain some article which is published in journal only. The white one is published in conference. Okay, the next one is the blue one. The blue one in the article was published in ICIC Express Letters in Japan. In our previous research, we use the principal component analysis as a feature extraction and logistic regression as classifier. The performance of the system gave the average accuracy about 70 more than 72%. This low accuracy of the system is due to the fact that logistic regression has the risk of overfitting that leads to low accuracy of the system. In this paper, we use a combination principal component analysis as a feature extraction and logistic regression, and then we propose a new technique, which is a combination of MRMR and modified logistic regression, and then the results of an improvement in accuracy, with the average accuracy up to 93, more than 93%. And then the last one, the article which was published in International Journal IGECE 2 months ago, and then we use relief and correlation based feature selection CFS as the feature selection technique, and then the classification techniques we use SPM. The several experiment and testing has been done. We analyze and compare the performance of relief and CFS with SPM. It showed that relief outperformed compared with CFS as microarray data classification for cancer detection. This one, the performance comparison. In this chart, we can see that we have tried colon tumor, lung cancer, and leukemia, and prostate, and then the accuracy more than 80%. But it's not enough. According to the medical doctor, it's not enough because we know that when we are give a diagnosis on and some medicine for one person, we would like to make sure that it's the accuracy should be precisely. And then conclusion and future work in this problem. Hopefully, we can integrate the filter algorithm, as I mentioned before, etc., in the process feature selection. And then we can use other classification techniques, something like AI or machine learning, to get high accuracy, but in low computational time. And hopefully we can collaborate with the participant which is interested in this topic. And then we are open to collaborate with everyone here. And then that's all my presentation. thank you, Dr. Desi. Thank you for all participants for attention in my speech. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Adi Wijaya, for their nice and interesting topic for research in cancer. So it's we know that when we go to hospital, so the most of patient in cancer room. I see that in here. Okay, ladies and gentlemen, let's give once again a big round of applause for Professor Adi Wijaya. Then for a Q&A session, please, no question. I will check chat room. Okay, Professor Adi Wijaya, I have question for you.
Okay.
The data, you got the data from the Kaggle or in website, is right? Have you
From Cambridge repository?
Okay, have you got I mean that collaboration in our hospital?
Not yet. Until now,
not
we have collaboration yet with our hospital. Sometimes in Indonesia, the data is very close.
yeah.
I have tried not in microarray data, but in data ECG, electrocardiography. But I got the data, but not from hospital in Bandung, but
yes.
from the hospital in Malang. I think depend on person which one or who one can collaborate with our research. I think it's not easy to collaborate data. The NDA, non-disclosure agreement, I think it's sometimes it's needed for us to get the data from the hospital, and memorandum of agreement from the university and the hospital. I think UNPAD is better in this one because it has the hospital, academic hospital, and can collaborate more than Telkom University, right?
Okay. Let's we join to a collaboration.
Okay,
actually,
thank you.
We also research about the EEG, EKG. So we have collaboration with doctor. Maybe next we will about the cancer and the point. Yes, the point we will make the prototype, and then we have also we have committee ethic. It's point for the committee ethic. This point it's important to research in health. This point for
because medical
for
record is very data privacy, right?
Yes, it's right. So now ongoing process in research in health about EEG and also robot COVID, and also for cancer. We also collaboration with CTEX Edward Technology. Maybe we will make the collaboration with Telkom University.
Thank you,
Okay.
Dr. Desi.
Okay, thank you, Professor Adi Wijaya. Next certificate session for invited speaker. I'm going to return the session for MC. Hello, Mr. Brilliant.
Okay, thank you, Mrs. Desi Novita. Up next, we would also like to present the certificate of our appreciation, which will be presented by me as the Master of Ceremony of today's event. And I would like to invite Professor Adi Wijaya, Director of Telkom University, to join me. And I would like to ask the operators to present and share screen the certificate of appreciation. Okay, so for the documentation team, you may lead the documentation session.
Thank you. Nice join in ICAIBDA 2021.
Okay, thank you, Professor. Thank you, Professor. Once again, a big round of applause to Mr. Adi Wijaya.
Thank you.
Okay, we would also like to give the certificate of appreciation to our moderator today, Mrs. Desi Novita.
Yeah.
So I would like to ask for the operators to present the certificate of appreciation. And for the documentation team to document the session.
Okay.
Okay, thank you, Bu Desi.
Yeah, thank you, Professor Adi Wijaya. We hope
Sehat
the
selalu.
session, yes.
Okay.
Okay, ladies and gentlemen, finally we come to the session one of presentation, the end of the session one of presentation. We would like to say thanks again for all the presenter for their informative and interesting talk, and to audience for your active participants. Hopefully the presentation will be beneficial for everybody. Thank you for your attention. Keep healthy and stay safely. We hope that the pandemic is over and come to the normal. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh. I will return the session to MC.
Okay. After this, we are going to have a break for about 13 minutes until 11 a.m. And I would like to remind you to fill the attendance form that will be spread out in the chat. So I hope the operator can share the link to the attendance form. And all participants are allowed to take a drink, have a breather, and maybe relax your muscles. So without further ado, I will see you again in 11 a.m. Thank you.
Thank you.
Okay, it is my pleasure to welcome you back. Welcome back to the second day of the first International Conference on Artificial Intelligence and Big Data Analytics. Okay, so before we start the next session, I would like to remind you to be seated, turn off your microphone, and once again, please kindly put your camera on and don't forget about your virtual background. Okay, um, I will be waiting for you all to be ready. Okay, we will wait at least for 1 minute. Okay, maybe we should start the second session of today's event. And for this session, I would like to introduce you to our second moderator of the day, Dr. Anindya Aprilianti Pravitasari, MSI. Dr. Anindya Aprilianti Pravitasari was born in the city of Tuban, East Java in April 1984. She studied statistics in her bachelor's, master's, and also doctoral programs. Her research focused on the data mining, machine learning, especially in unsupervised learning, and also the study of Bayesian modeling. In 2020, she received the Best Publication in Reputable Journal Awards from the Indonesian Ministry of Technology and Research, or Ristek BRIN RI. Currently, she is working as a lecturer and researcher in the Department of Statistics, Universitas Padjadjaran. Without further ado, let's welcome Dr. Anindya Aprilianti Pravitasari. Doctor, the time is yours.
Thank you, Mas Brilliant. I am so honored to be here as this moderator for this session today. Okay, in this session, there will be two invited speakers. Each speaker will be present their research in 20 to 25 minutes, and then followed by 5 minutes question and answer and discussion. Okay, the first one. The first one is from Universitas Padjadjaran. This is his CV. This is our first invited speaker, is Yudi Andriana, PhD. He was born in 1978 at Ciamis, West Java. He received his PhD in Belgium. He also served a lot here. First is as Vice Dean 1 FMIPA Unpad, and then as Head of Forum Pendidikan Tinggi Statistika or Forstat Indonesia, Deputy of Survey and Data Analysis in Jabar, Head of Study Program Master of Applied Statistics Unpad. Wow, he's so busy man. But we are lucky since he's here now and want to share with us his research, especially in the topic of flexible modeling. Okay, Mr. Yudi Andriana, PhD, the time is yours.
Okay, thank you very much, Bu Anindya. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Can you hear my voice? Is it okay with my, okay?
It is clear, Mr.
Okay, thank you very much. So the honorable all invited speakers of this conference, the organizers, and then also I see that there is Dr. Setiawan here as the head of the Department of Aeronautic Technology, and then also I think, yeah, okay, yeah, Bu Nursatil also here. So I would like to welcome also to everyone who attend. Thank you very much for attending my presentation here. So it's very nice to share what I have already done in the past, and currently I'm also still working on flexible modeling technique. So I would like to share my screen firstly. Sorry, I need to share my screen. So the host still disable me to share my screen. Okay, no, it's fine. Okay, if you look at this title, it doesn't mean that there exists a robust technique to solve the dimensionality problem of your data, but there is something inside. So the topic is about robust flexible modeling to overcome a curse of dimensionality, but there is something inside. There's a model called varying coefficient model to solve the dimensionality problem of your data, because in varying coefficient model, the coefficient can change with respect to another covariance. It means that the coefficient is not scalar anymore, but coefficient is a vector. So if you have, for example, two covariates, then one of them is the function of the coefficient. So it means that you are working on one covariate. So what is the meaning of curse of dimensionality here is that trying to solve the dimensionality by using varying coefficient model. So I need to make this disclaimer firstly, because maybe some of you think that there is a robust technique to solve the dimensionality problem. No, robust technique is something else. It can solve the problem with outlier, for example, something like that. Okay. So according to this topic, there are three things that I need to explain here. The first one is about flexible modeling, and the second one is about robust technique, and then the third one about varying coefficient model. After that, we try to combine three of them to a method called robust technique on varying coefficient model. Yeah. Okay. Here are the motivation. If you look at these two pictures, these two scatter plots here, so in the left-hand side, you will see that the model is very simple to solve this, to find the estimator of this kind of scatter plot. Yeah. So in the left-hand side, you will see that it's just linear. You will see, for example, that the model is just y is equal to beta null plus beta 1 x and epsilon. Yeah. Because you know at the beginning that when you do scatter plot, when you have this scatter plot, then you will easily make specification of your model, pre-specification of your model that the model is linear. Yeah. And then you try to estimate the coefficient of this model. You try to estimate beta null and beta 1. That's it. Having estimated the beta null and beta 1, the coefficients, I mean, then you can easily estimate the expectation of y, the conditional expectation of y given x. Okay. But if you move to the right-hand side, you will see that, okay, it's still fine, of course. You can work on parametric way. It means that you can specify the model at the beginning. For example, with polynomial with specified degree, for example, then you can work on parametric way. But the right-hand side is a bit more difficult than the left-hand side. Okay. So in the right-hand side, you start to a bit hesitate whether you can use in a parametric way or no. Yeah. And then if you go to the next slide, now become more complicated. You can consider that this one is a linear function, of course, and then also polynomial. Yeah, because you will see here in this section you will see like a linear function, but here you will see different. Yeah, starting from this, let's say around 12, then it goes down and then goes up. Yeah, and then again here linear. Yeah, if you use maybe after this slide, if you use linear model, then you will only find a linear curve here. What you need is trying to find a curve where the curve follow the characteristic of your data. More or less, the curve will look like this, for example. Yeah, this data is quite famous. If you are working on flexible modeling, it can be it's always used as an example. It's very nice example. If you are working on non-parametric regression, for example, and then everyone always start with this kind of curve because you cannot solve this curve by using parametric way. So then it means that you need to work on flexible modeling technique to find a curve satisfies or following the pattern of your scatter plot here. For example, using flexible modeling, then you can just simply put a function, an unknown function mx in your model, and then the mx can be estimated using several ways. Maybe in the next two slides, I will a bit explain about how to estimate the mx here. So previously, for example, like before, what I said before, here you just have, for example, y is equal to beta null plus beta 1 x plus epsilon. But now, instead of using the specific parameter of your model, but now you are using mx here, and mx is assumed is an unknown smooth function of x. Yeah. If you look at this one, it's nothing else than just this curve, this scatter plot. Yeah. If you work on linear model, you will have something like this. So this scatter plot is the same as this one. Yeah. If you work on linear model, linear regression model, then you will have this kind of curve. He doesn't care about the pattern in this area, in this one and this one. He doesn't care about the characteristic of your scatter plot, because he always consider that the model is always linear, whatever the situation of your scatter plot. But then, if you are working on flexible modeling technique, there are several techniques, like I said before. For example, I'm using here Nadaraya-Watson estimator and local polynomial and also spline. Then you will have this kind of curves. These three curves are perform much better than the parametric way. Yeah. So then, I think in several situations, in the real situation, you will face so many situations that you cannot solve using a parametric way. It means that you need to have a technique which allows that the curve will follow the characteristic of your data. Yeah. That's why we call it as a flexible modeling technique. So it's really data-driven way. Okay. So there are several approaches how to deal with flexible modeling technique. The first one, some authors work on kernel approach. There are several kernel approaches here. For example, the very old one, Nadaraya-Watson estimator, Geisler-Müller, local polynomial, and so on. And also another researcher working on splines. So there are two types of researchers who are working on flexible modeling technique, working on kernel and working on splines. And in splines also, there are so many researchers who are working on, for example, smoothing spline, thin plate spline, B-spline, P-spline, and so on. Tensor product P-spline, for example. Tensor product B-splines, or maybe truncated splines, and so on. There are several ways how to work on splines regression. Yeah. And nobody compare between these two. For example, in the kernel, if you are working on kernel, I think you can just pick one kernel function and then you try to optimize the bandwidth of the kernel. So you are not comparing the kernel function, the kernel density there, but you are comparing the how to optimize the bandwidth. Okay. Of course, I will not explain all of them, but I will just give some example how it works. Yeah, like before I said that there is an unknown smooth function mx, yeah, to estimate the curve. And then Nadaraya-Watson 1964, he proposed to you weight your y with a kernel function, this scale kernel function here. And then 1779, Geisler-Müller proposed another way how to estimate mx. And okay, for example, B-splines, the book, yeah, in the book also appear 2001, but of course B-spline is older than 2001. Yeah, he tried to approximate the mx by a linear combination of the basis B-splines. This B is basis B-splines. Okay. So then now we go to a robust technique. The function of robust technique, if you have outlier in your data. Of course, it is not wise if you try to simply remove your outlier in your data, because sometimes the outlier is important to be presented in your plot. Yeah, so you cannot simply remove. It is maybe important information that need to be put there, but then you need to make a model where the model contain outlier here. So in statistics, there is a way how to work on how to deal with outlier in your data without ignoring the outlier, without removing the outlier, because removing outlier is not a wise way. Then here you can try a technique called robust method in regression. There are several kind of robust technique in statistics. For example, here like MM estimation, one-step sign estimator, median regression, and quantile regression. What I want to use here is quantile regression. Why quantile? There are several advantages of quantile regression. Okay, so then I think it's better to use a robust technique than simply removing your outlier in your model. Except if you're really sure that the outlier is really typo, for example, you made a mistake when you when you write your data. But sometimes it is important information here. Okay. There's important information here. Okay, then now, why I'm working on quantile? Because in quantile, you don't need any specified distribution of your error term. Yeah, usually in statistics, you always assume that the error is always need to be normally distributed. But now, when you are working on quantile regression, you don't need any error distribution assumption. Yeah. Although in several papers, they are working on quantile regression, then they assume that the error has to be, they need to have Laplace or double exponential distribution, but it's not necessary. Yeah, most papers of quantile regression, they work without any error distribution assumption. So you can work with whatever the distribution of your error term in your model. Okay, here are the example of quantile regression. It's very popular example. Of course, everyone know about this curve. It's growth curve of your baby, for example. Yeah, you have several lines here, and then the dot one, for example, your baby. Yeah? This is the weight of the baby, and then this is for boys and it's for girl. It is quite old growth curve, but I think for getting the idea, it's still fine. Yeah, there are 9 lines here. Sorry, 7 lines here. And then maybe if you are working on regression only has single line. But now you have 7 lines here. So what's the meaning of these lines? Yeah, this line is nothing else than just the thought conditional quantile of the weight of the baby given the age of the baby. Yeah. Then this one is nothing else than just quantile regression curve. Yeah. So the thought is the level of quantile. For example, 5th, this one is the level of quantile. Yeah, and then you will know the position of your baby here, whether below the line or above the median line, for example. So what's the meaning of if the baby below the median? So of course, everyone has different how to they interpret the dots. But what, as far as I know, if they cross more than 2 lines, then something need to be investigate more. Yeah, but still around 1 line, for example, it's still fine. Like for example, my experience, my baby at the time, so always below the line here, but of course it's still fine. Why? Because at the time I'm using I used the growth curve from Belgium when I did my PhD. So I have different growth curve, where the growth curve coming from the babies from Belgium. Of course, we have different pattern between Indonesia and Europe. Yeah. So then it doesn't mean that if the dots are around, for example, 50% here, it doesn't mean that it has problem. Yeah, it depends on some situation, of course. Okay, coming back to our topic, that this 7 lines is nothing else than just the conditional quantile curve. Yeah, for the weight of the baby given the age of the baby. So then, what is the meaning of one curve here? For example, if you are working on median, yeah, median is this one, the middle line here, the median one. Well, level of quantile is 50%, and then the right-hand side is the level of quantile is equal to 70%. It means that more or less, if you are working on median one, more or less the data, 50% data below the line, and then the rest are above the line. And also here for 70%, it means that there are more or less 70% below the line, and then around 30% above the line. That's the meaning of quantile. Yeah, the meaning of quantile curve in the context of regression quantile regression, I mean. Okay. Now, how to get this kind of curve? For example, let's start with a very, very simple model. We have like multiple linear regression model. This is a very simple one. And if you are working on mean regression, yeah, this is very popular regression. Everyone work on mean regression, yeah, or we call it L2 loss function, or ordinary least square regression technique. For example, in the left-hand side, you assume that the conditional mean of epsilon given x is equal to 0, such that the conditional mean of y given x is equal to this signal part of your model. This one is signal part, because this one is equal to 0. Yeah, and when you are working on quantile objective function, which is more robust, and then you can have several curves there, and then you don't need any error distribution assumption, you assume at the beginning that the thought conditional quantile of epsilon given x is equal to a specific quantities. Yeah, specific quantity, I mean. a quantity would depend on tau here. For example, the A tau can be also equal to 0. It doesn't matter. Okay, such that the third conditional quantile of y given x is given by this expression. In the left hand side, you don't have any other term, but here you have A tau because of this one. Such that the third conditional quantile of y given x is this expression where your beta now depend on tau. Your beta depend on tau. Now, how to estimate beta tau then? Okay, if you are working on L2 loss function, you try to minimize this kind of function, this kind of loss function. I mean, yeah, it's quite popular. Everyone know about this one. Statisticians know about this one. While in the right-hand side, you try to estimate beta by minimizing the quantile loss function. Rho tau is quantile check function or loss function, or sometimes people call it pinball loss function. Why pinball? Because if you imagine like pinball game, the ball try to reach the minimum in the corner. Or people sometimes call it check function. Why check function? Because the function look like checklist. Yeah, where rho tau is defined by this expression. You give a positive weight tau to the positive residual, and then negative weight 1 minus tau to the negative residual. Yeah, you just removing square here, yeah, without square here, and then replacing by, you put rho tau in front of the loss function here. Okay, what are the different? If you are working on L2 loss function, then you have this kind of curve, square curve. While when you are working on quantile loss function, for example, if you give me tau equal to 75%, then you will have this kind of curve. And if you give me a level of quantile equal to 50%, then you will have this kind of absolute value curve. If you look at this one, then you will have that this one is exactly the corner of the curve. You will have problem with differentiability. In this point, the left limit and the right limit are not the same. So how to solve the problem if you don't have any explicit solution? Then there are several ways, of course. Yeah. So we're coming back to our objective function here. Yeah, you have this kind of objective function. How to solve this one? Like I said before, that this one is non-differentiable function because the left limit and the right limit are not the same. How to solve this problem? And then Kunkel and Bassett 78, they proposed to translate the quantile loss function into a linear programming problem. Yeah. Yeah, I'm sorry if it is more statistics or more mathematics for you. Okay. Okay. It means you need to translate the quantile loss function into a linear programming problem, something like this. Yeah, with this constraint. So the translation of this objective function is this two term. Yeah. And then now we use a classical notation of the LP problem. Everyone who has worked with linear programming, they know that in the LP problem you will need to minimize C transpose X, AX is equal to B, for example. And then now you have this kind of expression, and then now you need to translate what is C here, what is X, what is A, what is B. Yeah, using this expression. Yeah, and then you will know these quantities, these vectors and matrices. Okay. Okay.
Yudi,
Yeah.
your time is 5 minutes left.
Okay.
5 minutes ago.
Okay. Thank you for your reminder. Okay, now we go to flexible modeling technique. Yeah, the third part of your our topic. So we need, like I said before, there are several ways. Yeah, previously I use MX here, but now I'm using FX. We approximate the FX by a linear combination of the basis B spines, where B is a basis B spines. Yeah, and now how to estimate, because previously we don't have any coefficient here, but now I have coefficient alpha here. How to estimate coefficient using quantile objective function? Yeah, rho tau is quantile objective function. Then we can estimate your alpha by minimizing B spline objective function. But by using B spline objective function, we have a problem that the bigger number of knots, then the more wiggly the curve. Yeah, so overfit to the data, so it is unstable. Yeah. But then when you add a penalty term here, then it doesn't really influence by the number of knots. Yeah, it's more stable. Okay, it's more smooth, the curve. Okay, I will make it more a bit faster. Now we go to model, like I said before, Hasiti Bisarani said that in their paper said that this model can be also as an alternative to solve a dimensionality of your data, because now your beta is not a scalar, but beta is a factor as a smooth function of another covariate. In this specific case, I'm using t as another variable as an unknown smooth function of beta here. So for example, if you have x, then this one can be also x. Yeah, of course we need a background why we put x in your xp, for example, z in your xp, for example. And then there are several models in varying coefficient model. You can see from my paper appear in 2015. We call it homoscedastic model, simple heteroscedastic model, and general heteroscedastic model. Okay, simple because there is a constant here, there is a function of t here, and general because there is a function in the error term where the function it involves also the information of x and also t here. Okay, we implement our varying coefficient model to time varying coefficient model to longitudinal data. Yeah, let's say we have like the jet measurement of for subject I of y, t, x, and t denoted by yij, xij, and tij. So here I'm working on longitudinal observation. It means you have, for example, observation, not only observation, but also it is repeated. Yeah, it is repeated until, for example, ni for its individual I. So I put ni because it means that you are working on unbalanced design, such that the third conditional quantum of y given x and t is given by this expression. Now you approximate your beta by a linear combination of the basis B splines. B is the basis B spline with specific degree, nu k here. And the number of nodes is given by this expression, mk. Yeah, uk, I mean. Okay, how to estimate alpha? Then now you can estimate by alpha by minimizing what we call individual p-spline objective function here. Yeah, so alpha can be obtained, can be estimated by minimizing this p-spline objective function. Okay. So we have also several results, several theoretical results. So the first one is about consistency. What is consistency? Is about if you increase the number of observation, you need to guarantee that the number, the estimator getting closer to the parameter that you want to estimate. So fortunately, that our estimator is also consistent estimator that with this kind of rate. Yeah, 1 over n to the power something. It means that if your n is bigger, then the difference is smaller. Here, it means that the estimator is getting closer to the parameter that you want to estimate. And also we have a result for the asymptotic distribution result for your estimator. Appear in the paper, I think appear in 2016 or 17. Okay, here is the example about homosexual men who became HIV positive during 6 years. We measure about cigarette status, smoking status, I mean, and then age of the patients, and then also pre-infection CD4 percentage, and then the Y is the post-infection, the percentage of CD4. We want to see the effect of the covariate, and also we want to see how the different quantile give a different curve for every patient. Here are the coefficients, the varying coefficient. Yeah. So for example, this one is beta null, vary over time, here from time to time. Yeah. Also for all other covariates. Okay. Okay, I want to give you one example. Yeah, there are 3 patients here. Yeah, the first one non-smoking, where he is 18 years old and so on. Yeah, and the middle one is this one, and then the third one this one. There are 3 curves here. It means that we are working on 3 quantile level here. Okay, for example, in the middle one, and then we focus on the middle solid line here. It means that if the patient he is non-smoking, where he is around 33 years old, where the pre-infection is around 42. After 6 years in this position, in the median case, he will have around 25 CD4 cell percentage. Yeah. Okay. The post-infection. Okay. And then the line below here, maybe you can talk about the lowest the lowest risk, and then this one is the highest risk. Okay, how many time that I have? I mean, do I have still time to?
Your time is up. I'm sorry.
Okay, so the rest is about. Okay, I want to share at the end. Sorry, I will skip some part. if you want to know more about how, if you want to use this technique, I have already made R package already published in CRAN since 2015, I think 15, and then it developed by my colleague from Belgium, Ibrahim and Annelien Verhasselt. So Ibrahim add another function here, simultaneous test. There is test there, and also now my colleague in Unpad working on another develop the technique, not only time varying coefficient model, but also add space, so space time varying coefficient model using this kind of objective function. So thank you very much for your attention. I'm sorry for the time, and then maybe it's in some parts it's more theoretical for you, but yeah, that's what I did at this moment, what I'm doing at this moment. So thank you very much, and yeah, thank you, Bonin. Please.
Thank you, Pak Yudi. And now we start the question and answer session. All the participants are allowed to write a question in the chat box, and then I will read them, or if you may, you are allowed to open the microphone after I choose your question. Okay. Actually, I also have a question for you.
Yeah.
There is a lot of things in your presentation, but one I interested about is about the title. It made me a little goosebump. It's about a curse of dimensionality. What is the exactly meaning of the curse of dimensionality in this research?
Yeah, because sometimes we have problem with the dimension of your variable, right? We have so many dimensions, and then okay, you don't know how to do. Of course, there are several variable selection technique like lasso, group lasso, scarred penalty, elastic net, non-negative Gerard, and so on. There are several ways how to reduce the number of variable in your data, in your model, for example, yeah, by putting in the objective function. For example, like my colleague Annelien, he worked on non-negative Gerard on P-spline's objective L2 loss function. So he had something there, because he want to remove, yeah, of course, this kind of lasso and so on, it's about high dimensional data, yeah, where the number of observation less than the number of covariate, yeah, the number of variable. But then in my case, it doesn't mean that I want to reduce in the model, yeah, the number of covariate, but I want to put, for example, if there are two covariate, like I said before, then I want to use one other covariate as a function of your coefficient. It means that you are working on one covariate, look like that, but in fact you are working on two covariate there. So it reduces also the number of covariate that you want to predict their influence to the response. Yeah. So reducing the number by putting as a function of your coefficient. So that's why we call it varying coefficient. So vary over time, vary over another covariate, let's say, something like that. Yeah. And the word curse dimensionality appear in the paper of Hasti and Tibshani, who propose firstly about varying coefficient model in their paper. Yeah.
Okay, thank you very much. Is there any question more? Okay, Yudi Adriana, PhD, thank you very much. Oh,
thank you.
This is another question from Pak Setiawan Hadi. Pak Setiawan Hadi, if you may, you could open your microphone. Or I just read. Oh, it's not a question. Okay. It is common in computer science or math or stat. We say the curse of dimensionality means dimension of data is too large. With too large, however, it is not an easy task. If we reduce the dimension, we will lose some information from the data. So we do trade-off between raw data with large dimension and reduced dimension data. Okay, thank you very much, Pak Setiawan Hadi. Thank you very much, Pak Yudi Adriana, PhD, for an interesting session. And now we move to the next presentation. Okay. The next invited speaker, this is a legend of Bayesian statistics from Institut Teknologi 10 November Surabaya. Please welcome Prof. Nur Iriawan, MECOM PhD.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Prof. Nur is a head of Computational Statistics Laboratory in Department of Statistics, ITS. He was born in Blitar, East Java, Indonesia in 1962. In 1990, he completed a sandwich master program in computer science between Universitas Indonesia and University of Maryland, Baltimore, USA. And in 2000, he successfully completed his PhD degree in statistics from the School of Math and Stat in Curtin University, Perth, Western Australia. His success in developing neo-normal distribution, like Weisenburg, MST-Burr, and their computational estimation method. And since 2005, he has been a professor in Bayesian statistics, stochastic process, and computational statistics. Research interests including the statistical machine learning. ASC 14 Australia awarded him as the Young Statistician Award in 1997. Okay, I can't wait to hear the presentation. Prof. Nur Iliawan, the time is all yours.
Okay. Thanks to Anin. Thanks to all of the committee of this conference, and also I give the time for this talk to silaturahim to you all. Okay. May I share my slide? Yeah. Okay. Okay. I want to talk about the image processing for relating the VHD. That is the ventricular septal defect. Actually, the idea is how we can contribute our knowledge to the society. Maybe we all already study a lot, but what is our contribution to the society? If we think about the SDGs, that is the plan for 2030, number 3, I think. Number 3, the goals, number 3 from 17 goals, that is good health. How can we contribute to these goals? Actually, an healthy generation will help maintain the existence of our country. Yeah. That is the idea of our works. Our works is this is a compilation of the Ulfa Siti Nuraini, Nurinda, and also Bu Anintia itself in this work. Yeah. The content for 20 minutes, I hope that is enough time for presenting 7 parts of this idea to be talked about this one. Okay. The CSD is a structural abnormality of heart and blood vessel that appears from birth and is the main cause of child death from all congenital disorder. Even it's very small, around 7 to 8 from 1,000 newborn have CFD. But we remember that the SDGs idea is no one left behind. How we can contribute to this world, no one left behind to the child. That got the CHD. Yeah. And from 50,000 babies born here. I think that is so small, but that is so significant for our country. Maybe because of that, not all of the pediatrician can read the ventricular septal defect in our visual video for this baby. The hardware is the hole. There is the hole in the interventricular septum that separates the right and left ventricle. That is the hole. So the VSD happened in that baby. How to save him still alive? That is the idea of the no one left behind that we can contribute for the SDGs in this country, I think. And then, okay, that is the way to diagnose the GSD can be done using the ultrasound imaging examination to evaluate cardiac anatomy and hemodynamics. That is the tools. And how can we read this video as our data in statistics? So we have to do using machine learning, image processing combined there. And there is some work that already work in machine learning related to the echocardiogram. The first one, deep learning interpretation of echocardiogram, written by Amirata, David, and so on. The second, expert level prenatal detection of complex congenital heart disease from screening ultrasound using deep learning. The third one, image segmentation of the ventricular septum in fetal cardiac. There's a lot of out there. And the last one, I will give you the example detection of the cardiac structural abnormalities in the ultrasound videos. Our data is image, but actually we have to able to read the video first and then divide it into the frame, so the abnormalities can detect by the image of the frame. Heart abnormalities detection based on deep learning model using ultrasound video is still challenging, since CSD is relatively infrequent and ultrasound artifact like acoustic shadow also increase the difficulty of the image processing. Maybe we still imagine, how can we read the data? The data is a video. Yeah, the fast heartbeat make the movement of the image in the video is also relatively fast. The determination of the whole need to be seen carefully by looking at its frame. We cut the video to be so many frames, so each frame as an image. So we process each image as a frame of the video. This process takes a long time for a doctor to detect the VSD hole. Is there any hole or not? That is the question for the this work. Not all pediatricians can read the result of the visualization. Only specialists of pediatric cardiologists can read and determine the diagnosis and manifestation of CSD. Okay. we divide into part. The first one detection and the second one segmentation. How to detect, is there any hole between between the left and right herd, and then we do segmentation to see where is the hole. Okay, we apply this one. Maybe some of you already familiar with them. With one faster regional CNN and also YOLO version 4, that is detecting the hole between right and left chamber. And segmentation, we present two methods to architecture that we already done for during the segmentation. Recognizing the right and left ventricular chamber, so we can detect the left and right chamber, is there any connection or not. If there any connection, it means there is the hole. UNet VGG16 we combine together with transfer learning there, and also ResNet and UNet combine there, replace the UNet contracting path with ResNet. And this one, we replace the UNet contracting path using the VGG16. That is our data. Our data, child cardiac ultrasound video, normal and abnormal data, normal and abnormal video from Rumah Sakit DR Sutomo Surabaya. That is labeling done by the medical judgment that work with us. Okay, this is the data, the video, and then we have to make the frame image by image like that, and then we define as a training frame and also the testing frame. Number of video we have 15, 14 for the training and testing, and 1 video for validation. And we divide into frames there of 417, that is for train, for detection, and also this one is for segmentation. That is our data. And then this is the detection. The goodness of detection, we use the mean average percentage, we MAP, and then that is the bounding box, and then combined to the ground truths. So we mix mean average precision. For segmentation, we use two measurement of goodness of it. The first one, Jagat index, and the second one, loss. Okay. How the detection would be done? The first one, faster RCNN, faster for okay. The feature extractor input image are presented by the features, and then feature extractor include several conventional layers to extract the conventional feature map from the input image. This study used the Inception ResNet v2. So the input data, the frame would be put in the bottom and as an input for this network. And this architecture share the feature map together for region proposal network and also for the doing the classifier. Okay. This study employs a deep network method for detecting the VHD. It can predict the bounding box of the object called faster RCNN. This network contains two modules. The first module, region proposal network, that one for the generating region proposal, and the second one is detection network that uses the proposed region from RPN. However, both networks share the convolution feature map. This one, okay. This is the detail of this work. The convolution feature map obtained from the feature extractor is used as an input in RPN. The process generating regional proposal is carried out using a small network composed of 3 by 3 convolutional layer and followed by 2 sampling, like that. Okay, that is the detailed algorithm. And then the the process of generating regional proposal is carried out using a small network composed 3 by 3 convolutional layer and followed by 2 sampling, and that is what I said before. The convolution layer, namely box regression layer and box classification layer. That one, that is the detail of the algorithm. And then second one for detection, that is YOLO. Stand for you only look once. That is version 4. YOLO is an approach to deep learning that performs object detection. It is targeted at real-time processing and framing object as a single regression problem from direct image pixel to separate spatial bounding box and associated probability classes. This is the architecture of the YOLO version 4. Faster RCNN detector result. This is the first one. This is the detected hole between left and right in the baby heart. And next, this is the MAP convergence and also the loss function that already convergent there. And this is the result of the YOLO version 4. Detected result here. And also, okay, next. After we detect, then how we can segment the herd to be identification of the herd. The first one, UNet. This is the architecture of UNet. And then the data of UNet fluctuation in the data validation in the middle of iteration. This is part of the left architecture and the right architecture. That is the UNet combined with the VGG16 or also ResNet. We manipulate the left architecture. When fluctuation occur at the end of the iteration, the evolution of the metric will be very poor. This can be handled with a smaller learning rate, but sometimes a small learning rate will make the training process take a longer time and will not essentially handle fluctuation well. Okay, and then that is the new architecture. Combining the VGG16 to UNet with transfer learning. VGG16 resemble to the UNet architecture by adding an expansive layer consisting of several unsampling layers and convolution layer at the end of the VGG16 architecture. This is done until the overall architecture of the model is symmetrical and resemble the shape in the letter U. Yeah. That's why we call it as the UNet architecture. Therefore, in the architecture of the UNet VGG16 model, we will have a contracting layer, which is VGG16, and the expansion layer will be added later. Okay. Yeah. The second one, ResNet UNet. The part of the decoding, that is the ResNet, changing the left side of the UNet. ResNet UNet replaces UNet contracting path with ResNet. Advantages: could classify the frame which contain the detect, then segment it automatically. Okay, that is the step by step of the ResNet architecture. And then this is the result. Maybe the result is not as good as the detection algorithm, but we can see the Jakarta index and also loss index can compare between the method. And maybe we can see this is the result of the ResNet UNet. See, this is the ground truth and this is the ROI for the target, and this is the FIT16 with transfer learning algorithm. And this algorithm also succeed to show, to segment the is there any hole or not. Okay, in the last comparison result, it's a for detection MAP train and also test, we can see around 97% for the MAP, and also the segmentation. We can see that FIT16 UNet with transfer learning is, I think, better based on the loss and also the Jakarta, even that is for train and also for the test. I think the UNet FIT16 is better. This is the conclusion of the promoting of this method for detection and also the segmentation. This study had succeeded to run several architecture in detection and segmentation of VSD, faster RCNN, YOLO UNet, FIT16 with transfer learning, and also ResNet UNet. Hopefully, the result can help the pediatrician to detect the VSD. For VSD detection, the faster RCNN and YOLO made a bounding box. As a result, the comparison between two algorithms recognized that YOLO and faster RCNN could detect the VSD well. The two algorithms have about the same, around 97% of their MAP. For segmentation, the UNet FIT16 is transferring, I think it's better. We can see together before. It could produce the segmentation closest to the ground truth. However, the ResNet UNet also have the advantage to automate the segmentation. Yeah, that is the advantage of the ResNet UNet, which could recognize the defect of several frames in the VSD video. That is our talk. That's, I think we hope any question there, so we can see what is the significance of our idea to help people still healthy in supporting SDGs of Indonesia. Thanks, Bu Anin.
Thank you very much, Prof. Nur Iriawan. And now we start the Q&A and discussion session. The term is not general. The participants are allowed to write the question in the chat box, and then I will read the question, or if you may, you are allowed to open the microphone after I choose your question. Okay, Prof. Nur Iriawan. Actually, I also have a question for you regarding the expansion of the UNet architecture. It is could be a reason behind the combination of the UNet with FIT16 or the UNet with ResNet. What is the special of each new architecture?
Okay, thanks, Bu Anin. Hopefully, any other question beside this after this? Yeah. Okay. And we know the name of U is because of the architecture. That is the look like the U letter. Yeah, U letter. As we know, UNet is very good for segmenting medical data based on Ron Neuberger. Yeah, I think that is the inventor. However, the architecture is very complex. Yeah, very complex. When we run, we need a longer time to get the result. The parameters are very large, yeah, very big. The first idea combining UNet and VGG16 by replacing the UNet contracting path is one way to reduce the parameter, but the results are still in great quality. I think as our paper in the Telkomnika, 2019 or 2020, yeah, 2019, I think, yeah. The choice of VGG16 is because of its similarity to UNet contracting layer, yeah, and its number of parameters is also less than UNet. So it would help us to reduce the number of parameters to be estimated during the process of iteration. In addition, the VGG16 already has weight from parameters that are easily assessed. So we employ this weight to this new model. Therefore, it becomes light and fast architecture. Similar idea also UNet VGG16. The ResNet also, ResNet UNet, ResNet in the decoding architecture of UNet also reduce the parameter of UNet. We choose the ResNet since it used the at connection. So even though there are skip connection, it is not at the parameter. Otherwise, it could help to reduce the vanishing gradient. Yeah, I think this two proposal for ResNet combined to UNet and also VGG16 combined to UNet, that is advantage for us to get faster estimation and also to get the faster detection of our image. I think that's all, Bu Ani.
Okay, thank you. Thank you very much, Pak Nur Iriawan. Maybe another question from the participant? Or if you are too shy to a question, maybe you could email Pak Nur Iriawan in ITS. Maybe you could just join the research of Prof. Nur Iriawan in Bayesian statistics and statistical machine learning. Okay. Alhamdulillahirabbil alamin. This is the end of the session, and I hand it back to Mas Brilliant for the certificate appreciation and documentation.
Thank you to Dr. Anindya. Ladies and gentlemen, that was an interesting session, and now we are at the end of the second session. But before that, we are going to have the certificate of appreciation presentation for the speakers and also for the moderators. So maybe let's start with the first one is to Mr. Yudi Andriana to join me here, and I think the operators can help me to give him a spotlight along with the certificate. Okay, for the documentation team, you may lead the photo session.
Okay, thank you for the nice certificate and invitation. Thank you very much.
You're welcome, Mr. Yudi. Is it done? Documentation team? Okay, thank you, Mr. Yudi. And next, for Professor Nur Iriawan from ITS, I would like once again to ask the operators to present and share the certificate.
Yes, thank you.
Okay, to the documentation team, you may lead the photo session. Okay, next, last but not least, is for the moderator, our moderator, Dr. Anindya. Once again, for the operator, please, okay. Okay, now for the documentation team, you may lead the photo session. Okay, is it done?
Done.
Documentation team? Okay, it is done. Okay,
Thank you.
well,
Thank you very much.
you're welcome, Dr. Anindya. Thank you for the speakers and for the moderators for the end of the second session. But before that, we would like to say a big thank you to the other sponsors who have helped and support this event so that it can be carried out well. Namely, there is Dewa Web, Cakap, Dilo, Indigo Hub Bandung, Fami, Kodepolitan, Kolaborasi, Philoid, Cityscope, Jaggle, D-Health, and here we are going to present a video clip from one of our sponsors, Dewa Web. For the operators, you may proceed to start the video.
Nih, hal-hal yang bikin males bikin website. Lu udah bikin website lu sampai sedemikian rupa. Gak makan, gak tidur, gak pacaran, gak nikah, gak bisa move on. Terus pas lu mau publish, nama domainnya lebih panjang dari kasih ibu. Gak cuman itu, pas lu buka, lemot banget. Bahkan loadingnya lebih lama dari nyusun undang-undang. Undang-undang woy, bukan undangan. Oke, misalnya pun udah berhasil kebuka nih. Karena gratis. Tahu-tahu ada yang datang nggak diundang. Pulang nggak diantar. Dan seperti 7 miliar manusia di bumi lainnya, lu kira lu akan dibantu sama customer service. Halo? Dengan customer service hostinggaja.com? Website saya kena hack nih.
Gak usah hubungin gue lagi.
Dan ternyata, customer service-nya lebih susah dihubungin dari mantan.
Hai kamu yang lelah dengan hosting abal-abal? Ahihahaha, saya punya jawabannya. Pakai Dewa Web aja. Kamu nggak perlu khawatir dengan alamat domain yang terlalu panjang. Kalau domain yang kamu sudah keambil, kita nggak cuma bisa pakai .com kok. Ada .id, my.id, web.id, .net, .co, dan sebagainya. Dan dapat domain gratis loh untuk semua paket cloud hosting.
Kalau lemotnya?
Dewa Web menempatkan kamu di server cloud tercepat dengan unlimited bandwidth. Nggak ada lagi lemot-lemot. Kenapa?
Takut kehack?
Gak perlu khawatir kalau itu mah. Dewa Web melindungi website kamu dari serangan hacker, virus, malware, dan resiko kehilangan data dengan memberikan cloud backup gratis. Dewa Web sudah bersertifikat keamanan ISO 27001.
Efektif iya, cepat iya, aman pasti. Kurang apa lagi ya? Oh, kalau misalnya kita butuh bantuan gimana?
Tenang! Ninja Support bakal selalu ada sekejap dalam boot kamu.
Halo, dengan Dewa Web. Ada yang bisa saya bantu?
Nah, tunggu apa lagi?
Bang, kameranya sini bang.
Nah, tunggu apa lagi? Urusan hosting dan website, ingat, Dewa Web!
Cari hosting yang aman, Dewa Web.
Okay, well, that's the video from Dewa Web. For me personally, as a communication student, that was a very creative advertisement. And if you want to create a website but don't know where to host it, don't be confused because we know the best cloud hosting service in Indonesia, namely Dewa Web. Dewa Web is the best and most trusted cloud hosting service provider in Indonesia. And apart from being safe, fast, and reliable, Dewa Web ensures that your information and data remain safe because Dewa Web is the first in Indonesia to be certified ISO 27001 27001, which is an international standard certification that ensures the security of your information and data. Dewa Web is also ready to handle your website or hosting problems 24 hours a week, so don't worry. If your website has problems, Ninja Support Dewa Web will definitely help you. And well, what are you waiting for? Let's create your website right now for friends, and any of you who are still confused or want to know more, you can directly ask the Dewa Web Support Ninja at dewaweb.com. Well, we also would like to thank the media partners who have supported us. And because this event is organized by Research Center of Artificial Intelligence and Big Data UNPAD, or AIDA, co-organized by Fakultas MIPA UNPAD and Himatif FMIPA UNPAD, and sponsored by IEEE, Comsoc, and Universitas Padjadjaran. And after this, we are going to have a break, and this one is a little bit longer because it is for 50 minutes until 1 p.m. Before that, I would also like to remind you, for all participants, to please fill out the attendance form that has already been shared by the operators at the chat. So I would like to remind you that once again. And all participants are allowed to take a drink and eat your lunch, or maybe pray and have a breather, and maybe like relax your muscles. So without further ado, I will see you again in 50 minutes. Thank you. Permisi kepada operator dan panitia, apakah bisa mulai lagi? Okay, baik. I think we can start the third session. Okay, good afternoon, everyone. It is my pleasure to welcome you back again to the second day of the first International Conference on Artificial Intelligence and Big Data Analytics. I hope you had a nice break. And now, before we start the next session, I would like to remind you again to be seated, turn off your microphone, and please kindly put your camera on. Okay, for this session, I would like to introduce you to our third moderator of the day, Mrs. Mira Suryani, SPD MCom. Ms. Mira, she studied computer science at bachelor's degree at Universitas Pendidikan Indonesia and magister degree at Universitas Indonesia. She is a member of IEEE Computer Society. She is also a certified Microsoft Certified Education since 2016. And now she joined Computer Science Department, Universitas Padjadjaran as lecturer from 2015. Currently, she is also pursuing a PhD in Computer Science doctoral program in Universitas Indonesia. And finally, she has 58 publications indexed by Google Scholar and Scopus. So without further ado, let's welcome Mrs. Mira. To Mrs. Mira, the time is yours.
Okay, thank you, Brilliant. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Is my voice clear?
Very clear, Miss.
Okay. Yeah, thank you. It's an honor for me to host this session over the next hour with this amazing speaker and participants. First, I would like to thank to fourth invited speaker, Associate Professor Tis Dr. Wan Muhammad Amir from University Science Malaysia, and the fifth invited speaker, Associate Professor Gus Ankus from the Neosia University India for joining us today. Each presenter is given 20 minutes to deliver a presentation and continue with the 5 minutes of Q&A session. Before listening to the presentation, allow me to convey a brief biography of Associate Professor Tis Dr. Wan Muhammad Amir bin Wan Ahmad. He is actively as a lecturer and researcher at University Science Malaysia. His current position is University Lecturer, grade DS 53. His main current research areas are in statistical methodology building and its application, and also in applied science for public health using statistical software. He has published 55 books. He is also the main or corresponding author for 100 plus publication and become co-author for more than 300 publication in Scopus and Web of Science. He actively become an academic assessor or member of board of studies such as Future Dental Student Program. Okay, maybe the operator can mute Mr. Ardes. Okay, yeah, we continue. And not only an author, he also become a reviewer for more than 15 books, journal, and conference, such as Journal of Mathematics, Science, and Informatics, and International Statistic Institute, World Statistic Congress in 2019. Okay, without further ado, Dr. Wan Muhammad Amir would like to share about the craniofacial research, a methodological development in biostatistics. Dr. Wan Muhammad Amir, please, the screen is yours.
Okay, thank you very much. Okay, good afternoon to all. Thank you very much. Yeah. Okay, now I'm going to share screen with you. Okay. Okay. Who's disabled participant screen sharing? Oh, I cannot go to my screen. Can someone help me? I cannot go to share screen. Why? Host disable participant screen sharing.
Mr. Operator, please, can you open share screen for Mr.
Yeah.
Amir?
Okay. 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 Yeah. I think that we can see the screen now. Okay, Assalamualaikum and a very good afternoon to all of you. First of all, I would like to thank you very much for giving me an opportunity to deliver, invited speaker here for this international conference, ICA IBDA 2021. Okay, thank you very much. I am Wan Muhammad Amir, the Statistic Coordinator in School of Dental Sciences. Before we go further, I would like to share with you about USM. USM is one of the top university in Malaysia. Okay, and then we have 4 campus. We have main campus, engineering campus, okay, advanced medical and dental sciences institute, and health campus. In health campus, we have 3 schools here: medical, dental, and health sciences. Okay, this is my school, okay, dental sciences. Okay, now I'm going to share with you what we have in the dental sciences school here. Okay, research in the dental sciences here, which is comprised of anatomy of the craniofacial region here. Okay, craniofacial region, biochemistry, molecular biology, biomaterials, conservative dentistry, craniofacial, dental public health. Okay, and then we have development of biology, molecular biology, forensic dentistry, oral maxillofacial, oral medicines, orthodontic, pediatric, pathology, periodontic, pharmacology, physiology, and prosthodontic. All this is, the scope and discipline that we offer in the School of Dentistry. As you can see here, there is 2 types of research which is conducted, okay, under public health here. You can see the first part, which is emphasizing statistical application towards study case, meaning that we are using the statistical analysis tools for the analysis. And the second part, we develop the specific statistic method. Okay, when we talk about developing a statistical methodology here, we need the computational methodology, especially on the biostatistic part. When we talk about the biostatistic, we need people who are very specialized, not by the usual statistician, because we are dealing with the very specific terminology and definitions. Okay, in the dental, we call them as a craniofacial biostatistic, and in medical, we have medical statistic. Okay, what we are doing now in the statistical analysis here, we serve, okay, as a biostatistician, craniofacial biostatistic for the researcher, and also we develop the statistical methodology building for the research, as you can see as mentioned in the slide. Current research focus in craniofacial biostatistic comprised of 2 sections. First section is develop statistic methodology, which is we are modify, okay, some of the previous methodology. We extend from the previous methodology and we improve the previous methodology by integrating the existing statistical methodology to perform research. You know, and then we hybrid, okay, one of 2 method we are trying to hybrid, and then we are trying to come with the very robust statistic. Using statistical tool also here, the second part is about using statistical tool to perform the study. Meaning that using existing statistical methodology to perform the research. Okay, when we talk about the skull and the face in the medical term, you can see here, I give you 8 cranial bones here. Okay, we can see here craniofacial refer to the bone of the skull in medical terms here. When we talk about the fracture here, what we are doing here, we try to illustrate and try to have the connection with the statistic here. This is bone which having the fracture. At hospital USM, okay, most of the cases reported, especially in trauma, they're having an accident, which is related to the bone fracture. Okay, most of the cases they are surgically treated rather than conservative. from closed reduction to open reduction or RIF, okay, internal fixations. Okay, due to the increase of facial bone here, due to the increase in the facial bone, soft tissue implant has become more and more common here. Okay, in the current report, okay, like last year, we have 200 cases, 45% patient received the surgical treatment, while other have the 35% conservative treatments. Okay, if you see the bone here, okay, if you see the bone here, the facial skeleton for the bone, I mean, this facial skeleton comprised of 14 bones. They are prone to fracture by a small force applied in opposite direction, meaning that all of, I mean, our skull here, they are so fragile. When we having the accident, the most, I mean, common part will be damaged. Okay, due to the large magnitude of forcing during trauma, frontal bone fracture are always associated with the concomitant injuries to the cranial, intracranial, ophthalmological, and maxillofacials. The mid face fracture, which is, we can see here, we see the skull here, zygomatic bones, okay, maxilla bones and nasal bone. This is the most common skull fracture happen when we those having the accidents. Okay, it was reported, okay, worldwide mid-face fracture having 72.5%, mandible 24.3%, orbital fracture on the floor, which is having 22.3% of the cases, and Lefort 2. And the Lefort 2 fracture was present about 45%, which varies worldwide here. Okay, in this study, what we are doing in the dental school here, okay, we have two general objectives here. First, computational methodology building for craniofacial research, okay, biostatistic research. Specific objective to determine and validate the relationship between frontal bone fracture and other bone that are closely related. As you can see here, okay, this is, I mean, the modeling that we are trying to have for which is can represent the accident, which is involving the bone, frontal bone skull, which is, I mean, this equation, this modeling with the help of the expert opinion, okay. Okay, we have the frontal bone skull. We see from the clinical importance, they are related to the gender, Lefort 3 fracture, mandibular symphysis, and mandibular condylar fracture. This is, I mean, where is mandibular symphysis is, I mean, around here, under the chin here, and the Lefort 3, which is I colored with the green color, and this is the frontal bone skull, which is, I mean, the most important part, which is, I mean, we have brain here, and then when someone accident, they will give a crack here, and then when this one crack here, they might have associate with another, like a gender, Lefort 3, mandibular symphysis, and condylar fracture. Material and methods here. Okay, when we are doing the research in the dental school, this is, I mean, the flow that we already, the flow that is being established. Selection about the study design, and then we must get the ethical considerations. And then we followed by sample size determinations, okay, and then we need to, I mean, consider about the inclusion criteria and exclusion criteria for the sample size selection, meaning that the inclusion and exclusion play a very important roles. And then we go about the sampling technique procedure, okay, and then we develop the methodology in ARC syntax, and after we develop, we are using the statistical analysis here, okay, this one, okay, we will develop and we do the data analysis here, and then we get the result. About talking about the study design here in dental school, we are determining this kind of study as a retrospective computational study design. Okay, the area in USM, and this is all the part is very important here. We have the reference populations, patient with the craniofacial fracture in East Coast of Malaysia, sources population, patient with craniofacial fracture in East Coast Malaysia who presented in hospital USM. Then target population, patient with, okay, craniofacial fracture in East Coast Malaysia who present to the oral maxillofacial clinic accident A&E department, oral maxillofacial ward and recovery area of the general OT. Okay, sample frame which is getting from 2014 and to December 2016. The subject criteria, because this is very important when we in the medical or dental sciences, the subject must be clearly select with these inclusion and exclusion criteria. Okay, those, if you can see here, the inclusion criteria here, we set complete hospital record here. As such, this one, all the information is being, is being complete, then we can take as a sample. Patients who do not complete and unavailable hospital record will be excluded. Okay, and then the sample size, as you can see from here, this is patient register, and this is sampling methods, proposed sampling. And then when we performing the research, the ethical approval must one of the criteria. Okay, we obtain the ethical approval, and then this is the data collection, phase 1, list of patient, and phase 2, and phase 2 with the okay, the phase 2 will all the retrieving all the hospital record, each folder will be through as a mean, and we select those who are eligible to be in the sample. And then the methodology development using R syntax. Okay, the first part of the analysis, we emphasize on the data collection and variable preparations. Second part, the syntax developments for the bootstrap method, and we are using also multiple logistic regressions. And the third part is implement of the bootstrap method and multiple logistic regressions. And also by the time also we also develop the syntax, okay, for the multi-layer perceptron. This is for validation of the variables. And then after that, we implement the multi-layer perceptron NLP. And after that, we do also the assessing of the goodness of the developed models through MAD, mean absolute deviance, for actual and predicted data. And we also assessing the accuracy of the developed model. And also we parallel with the clinical expert. Okay, this is, methodology that we use for the dental sciences here. This is an illustration here. You can see straight away. Okay, this is from the patient inclusion exclusion criteria. We do bootstrapping, we do analyze. Okay, the dependent variable. Okay, we get the output dependent variable, and then we validate through the multi-layer perceptron. Okay, and then with parallel with the clinical expert, and we validate the model. Okay. Okay, this is, example that we have done here. Okay, data from patient with underlying the craniofacial fracture visited in USM, and this kind of data from the record. Okay, this data we are collecting from the emergency department and unit of record. Okay, which is frontal bone, we have gender, Le Fort 3, symphysis, and condyle. All the variable here is being selected according to the clinically important and also to the opinion of the specialist. We do the bootstrapping because we want the parameter that obtained from the result is being accurate and reliable here. Okay, and then we do the logistic regression here. Okay, and then we perform the equation by considering the maximum likelihood, okay, methods here. Okay, and then this is the result here. You can see directly. Table 3 here, okay, show the combining all possible variable, which the highly accuracy coming from the input of gender, Le Fort 3, and mandibular symphysis and mandibular condylar fracture. Patient who have mandibular symphysis fracture has a 60.8% lower chance to break in their frontal bone than patient who do not have the mandibular symphysis fracture. This is, one of the finding that we found here. And then we also use the multi-layer perceptron to validate the result. As you can see here, okay, we try one by one of the variable. We are trying to see which, giving the good result here, and also parallel with the specialist expert opinion. And we found that, okay, 4, 1, 2, 3, 4 here, giving the MAD very low and accuracy is very high, 99% here. Okay, and then this one, this is, okay, we go to the previous, this one. This is the architecture of the MLP, 1 hidden layer with 4 input out nodes and 2 hidden nodes here. Okay, this is, the result here. As a discussion here, we can say that on the methodology building perception, the proposed methodology provide a very good strategy to determine the most common fracture related to the bone fracture. Meaning that we are proposing the method here by considering bootstrapping, multiple logistic, and validate by multi-layer perceptron, showing the high accuracy. Okay, and the proposed methodology also support by the clinically based theory on the association of the frontal bone fracture with gender, Leaford tree, and mandibular symphysis, and also the mandibular condylar fracture. The proposed methodology, the proposed methods, okay, are able to show the superiority of the bone fracture relationship by determining the skeleton weakest mandible bones. The mandibular condylar fracture has 77.4 decrease the odd to the frontal bone than those without mandibular condylar. Okay, the mandibular symphysis fracture has 60.8% decrease the odd to the bone fracture than those without mandibular symphysis. As a conclusion here, okay, through the proposed methodology, we are able to obtain and harmonize the hybrid methods, which is resulting in high accuracy and reliable models. We successfully use the proposed method, and this is very useful to estimate the probability of event, predict the odds of being a case, including determining a relationship between feature and also the probabilities of outcomes. The proposed method discloses the important detail about the sample analysis, okay? Especially as such the nature of relationship between two variables. And then this is also being validated by the MLP process, and also this result, you can see that to validate the result, which is proposed a technique, the maxillofacial surgeon will check all the related bone fractures here. For the future direction, the proposed methodology can be optimized, the fracture determination in craniofacial study, especially in frontal bone, to progress from retrospective computational study design to a clinical application. Step-by-step approach is required. Okay, this is the team that we are doing the research together, which is, thank you to Dr. Muhammad Faisal, oral maxillofacial specialist, okay, Dr. Noraini, family medicine specialist, and Noor Azidan Aling, senior lecturer in UMT, and oral medicine, Dr. Muhammad Azim. We are work together in order to, to do some, on the research. With that, thank you very much. So I give the screen to Ms. Mira Suryani.
Okay, thank you very much, Dr. Wan Muhammad Amir, for the very interesting presentation. Now we have a question here from Miss Linda. I will read for you. There are some hyperparameters in MLP. What is the best method to find the optimal hyperparameter? Maybe Mr. Wan Ahmad can answer directly, please.
Can you repeat again? Hyper.
Okay. There are some hyperparameters in MLP. What is the best method? What is the best method to find the optimal hyperparameters in, especially in your research?
In my research, we are considering on the multiple logistic, and then the function of the logistic regressions. Yeah.
So the optimal function of logistic regression, right?
Yeah, meaning that we also based on the maximum likelihood.
Okay, the maximum
just the
likelihood
MLP
is the
for only for the validations according to the perceptions of the specialists. We try to harmonize.
Okay, so you combine three method, right?
Yeah, we are combining three method in order, but sometimes we are very difficult to get data from the accidents. Okay, and then we have to do the bootstrapping in order to, to accurate the parameter estimations.
Okay. What kind of format data that you use in your research? Is it text or including image or anything else?
We base totally on retrospective record, meaning that we go to the unit record and we collect the record one by one. And also we are waiting at the emergency A&E departments when there is accidents, and then the specialists busy with their work, and we are taking the parameter.
Oh, it's very interesting because the medical data is it's not easy for us to gain that data.
Yeah. We
Okay.
also having the, when we are doing the medical or dental data, we need to get the approval from the ethic
Right.
committee. Okay,
Yes.
it's very hard. Sometimes it taking a lot of procedure. Yeah.
Okay, okay. Thank you very much for your answer. Okay, and now we will move to another interesting presentation. Thank you very much once
Thank you,
again.
thank you, thank you. Have a nice day
Okay.
to all. Thank you very much.
Yeah. Okay. Yeah. Okay. Thank you very much for Mr. Dr. Wan Muhammad Amir. And now we will listen to another interesting presentation from our fifth invited speaker, Associate Professor Ghosh Ankus from the Neosia University, India. Okay, before the presentation starts, allow me to convey a brief biography of Associate Professor Ghosh Ankus. Professor Ghosh Ankus is senior member of IEEE, fellow of IETE, currently working as associate professor and head of School of Engineering and Applied Sciences, the Neosia University. He has received his PhD degree from Jadavpur University, India in 2010. He was a research fellow of Advanced Technology Cell, the RDO, Government of India. He was awarded National Scholarship by HRD Government of India. He has outstanding research experience and published 6 edited books, 4 from Springers and 2 from Elsevier's, 3 national and 8 international patents, and more than 100 research paper indexed by Scopus and Web of Science. He is serving as an editorial board member of several international journals, including chief editor. He has more than 15 years of experience in teaching, research, as well as industry. His UG and PG teaching assignment include microprocessor and microcontroller, AI, IoT, embedded and real-time system, etc. He has delivered keynote or invited lecture in a number of international seminar and conference, refreshes courses, and FDPs. He has guided a large number of MTech and PhD students. Dr. Ghosh is an active member of IEEE and organized a number of seminar and workshop in associate with IEEE. He is an editor and organizing committee member of the conference series like GUCON, ICCCA, ICEEE, ICAC-ICT. He is a global jury member of National Entrepreneurship Network Mentor Group. He has received award for contributing in Innovate India from ICTE DST Government of India in 2019. Without further ado, Prof. Ghosh Ankus would like to share about machine learning for autonomous driving today. Professor Ghosh Ankus, are you ready?
Miss Mira, I think
Yeah.
Professor Ankus hasn't attended yet, hasn't joined
Okay.
the session yet. So I guess we could give the certificate of appreciation to Mr.
Okay. Yeah.
Dr.
Okay. So I return the event first to Master of Ceremony for awarding the certificate first. Okay. Thank you, brilliant.
Okay. Thank you, Mrs. Mira. Up next, we are going to have another certificate of appreciation presentation, which will be presented again by me, the Master of Ceremony of today's event, to the speaker, Associate Professor Dr. Wan Muhammad Amir of University Science Malaysia. I would like to ask the operators to spotlight me and Dr. Wan. Dr. Wan, are you there?
Yeah, I'm here. Thank you very much.
Okay.
Yeah.
For the documentation team, you may lead the photo session.
Okay.
Okay, is it done? Documentation team?
Okay, yeah. Yeah, everything's okay.
Okay, I think it's done. Once again, thank you to Professor Dr. Wan Muhammad Amir bin Ahmad from University of Science Malaysia. Once again, I would like to say my appreciation to you, and back to you, Mrs. Mira.
Okay, thank you, Brilliant. Shall we wait for next 5 minutes or yeah, okay. I think we have to wait 5 minutes. Okay. We hope Professor Gus Ankus can participate joining us in 5 minutes. Okay, Professor Ankus joining us. Okay. Wait. Okay. Yeah. Okay, Brilliant. We will start again the session. Okay. Yeah. Now we will listen to another interesting presentation from our fifth invited speaker, Associate Professor Gus Ankus from the Neo-Nasia University, India. Before the presentation starts, allow me to convey a brief biography of Associate Professor Gus Ankus. Prof. Gus Ankus is senior member of IEEE, fellow of IETE, currently working as associate professor and head of School of Engineering and Applied Sciences. He has received his PhD degree from Jadavpur University, India in 2010. He was a research fellow of the Advanced Technology Cell, DRDO, Government of India. He was awarded National Scholarship by HRD, Government of India. He has outstanding research experience and published 6 edited books, 4 from Springer and 2 from Elsevier. He has 3 national and 8 international patents and more than 100 research papers indexed in Scopus and Web of Science. He is serving as an editorial board member of several international journals, including Chef Editor. And he is a global jury member of National Entrepreneurship Network Mentor Group. He has received award for contributing in Innovated India from AICTE DST Government of India in 2019. Okay, without further ado, Professor Gus Ankus would like to share about machine learning for autonomous driving. Professor Gus Ankus, please, the screen is yours.
Thank you, Professor Mira. Thank you very much.
Yeah.
I'm just sharing my screen. Madam, is it visible?
Yes, perfectly.
Okay, and is it in full screen mode now?
Yes.
And Madam, the slide is changing?
Yes.
Okay, thank you.
Yeah.
Thank you. So, so thank you, Professor Meera. Let me read this. Yeah. So these in this talk, basically, I'll be going to discuss on the various machine learning applications on which using which we can use in autonomous driving. You know, in last few years, these autonomous driving, autonomous vehicle is a buzzword. You can say buzz technology, and a lot of researchers are working on these autonomous vehicle technology. So I'm not going to discuss things on autonomous vehicle. I'll be focused on our research on autonomous vehicle, autonomous driving. Basically, we have done some research on autonomous driving technology with machine learning applications, how machine learning can be assist in these autonomous vehicle technology, right? So in this talk, basically, I'll discuss on some of the scopes or area where people, researchers can work on these autonomous driving technology using machine learning technique, and whatever research we have done in these field of technology, autonomous driving technology, that I'll share with you. So the outline of this talk will be going like this. Introduction, we'll start with some basic introduction of self-driving or autonomous vehicle, then working principle and algorithms of these autonomous vehicle technology, then how these machine learning can be applied in these autonomous vehicle technology and technology, working technology, and integration of supervised and reinforcement learning there, and some functions of autonomous driving like collision avoidance, like traffic management, and those things we'll discussed, and how these deep reinforcement learning can be applied there. And also we have done some tests, so those test results will be shared with you. And finally, the risk of self-driving and advantages as well as conclusions. So let me start with these. Just a minute. Yeah, perfect. So basically, there has been a paradigm shift from the classical vehicle to autonomous vehicle. And if we see the classical vehicle that were available in the last few decades back, that was you need a huge driving skill to drive with these classical vehicle. However, in last few years, or you can say in last decades, we are finding some semi-autonomous vehicle where you cannot say it is an autonomous vehicle because it cannot run autonomously. However, in this kind of vehicle, some driver assistants are available. Driver assistant, like you will find cruise control. You can find some warning system where red light warning systems are there, where different traffic warning systems are there. So that kind of different driving assistant systems are available in the semi-autonomous type of vehicle. However, we are going to nowadays, people are trying to make a fully autonomous vehicle. And you have seen some of these autonomous vehicles currently in the market. They are in the testing process, like Google car. You have seen. So this kind of car are using various equipment like LiDAR system, like video cameras, radar, and ultrasonic sensors. So these sensors are basically takes the input from the environment, and according to the input, these inputs are fed to the central computer, and according to these input, they are taking the actions. So these are basically the paradigm shift from classical vehicle to semi-autonomous vehicle to nowadays fully autonomous vehicle. Those that yet to come in the in the real life traffic system. So this is our goal. This is our objective. So therefore, let us see how we can help to make these fully autonomous vehicle. So I'll here share you with some scopes of research work in these autonomous car. So basically, we have worked on a very though here we have seen there are various sensors available. Basically, 4 sensors are integrated into these autonomous vehicle, like LiDAR, video cameras, radar, as well as ultrasonic sensors. But here in these, what we have done research on, basically we have done research on video cameras, feed of video cameras. So whatever the video camera feeds, so we have worked on those videography. So those work are basically on the object detection, how to detect the object, collision avoidance, different collision avoidance algorithms we have discussed. Then traffic management, how the traffic management can be controlled, then and finally path planning. So these are the scope of research that we have explored, though there are various other scope of research available in these autonomous cars. So whatever the research we have explored, we have shared in these books. So we have published 3 edited books, 1 from the Elsevier and 2 from the Spingers. So basically on the machine learning for robotic applications, and these autonomous vehicles comes under robotics car or robotic applications. So in these 3 books, basically we have given around 12 to 14 chapters on these autonomous vehicle. So whatever the research we have explored, that I'll share with you in this talk. So yeah. So if we see the human driving cycle, basically whatever in the robotics or in the in the most of the kind of machines that humans have invented, is basically based on the nature. So principle of the nature. So basically in case of robot also, we have seen we are mimicking the human being, right? So here also in autonomous driving, we are basically mimicking the human driving principle. So let us see what is the human driving principle. So human driving, if you see the principle of human driving, it is basically 4 steps are available. 4 steps we are doing when we are driving a car as a human. So what are those 4 steps? Those 4 major steps are perception, scene generation, planning, and action. So what are these? Perception, scene generation, plan, and action. These are basically in perception, what we say is a perception in these. Here we can through our naked eyes we can see the traffic signal, we can see the road surface, traffic movement in front of us, as well as we have to see the mirrors. So this is called perception, and as per the perception, we generate the scene as per our sensory organ with eyes and our brains. We generate the scenes. This is the scene. Some cars are there, some moving cars are in front of us, some buildings are in front of us, or some trees are in front of us, and some signals are there. So this is all these as a whole we can say is a scene. So these scene we have, first we perceive the things, then we generate this scene into our brain, and according to the scene generation we planned how to drive. Should I drive straight? Should I go to right, or should I go to left, or is there any obstacle? So therefore we have to bypass the or avoid the obstacle. So according to we have to plan, and as per the plan we have to take the actions. That means we have to run the car. So this is the 4 major steps while we are driving. First one is perception, then scene generation, then planning and actions. So therefore, since we are mimicking the human behavior, human driving skills, human driving technology, so the same things applies in the autonomous vehicle also. So there also these 4 steps are available. We are applying perception, scene generation, planning and action. So however, these planning and actions comes under the under the hardware part, because actions means hardware will be taking the actions, right? So in our research, we have used these first 2 steps only, that is perceptions and scene generation. Means we have to you have to detect and recognize the traffic signal, whether it is showing red, green or amber, or whether it is some signage is there, we have to turn left or turn right. So we have to detect those things, and we have to generate the scene, whether what is there in front of us, whether it is a moving vehicle or some pedestrian is there, or the pedestrian is moving, or we have to also generate the scene like this pedestrian is trying to cross the road, so it can come in front of us. So that things also we have to come in our mind. So therefore these first 2 steps in our research, we have done research on these first 2 steps, that is perception and scene generation. And for these first 2 steps, we have used a different machine learning algorithm to make the to make these scene generation accurately, and we are trying to make this accurate scene generation and trying to make this as 100% accurate, so that because these things are the most important, perception and scene generation, because this planning and action will be based on these perception and scene generation, right? So therefore, if there is an error in the scene generation, if you cannot detect a pedestrian, then you cannot plan, and accordingly you cannot take the action. So the vehicle can collide with pedestrian. So therefore, these first 2 steps, perception and scene generation, is the most important factor for an autonomous vehicle. And we have worked on these first 2 steps, perception as well as scene generation, right? So we have used different machine learning algorithm here for this perception and scene generation, and these perception and scene generation has been achieved through supervised learning and object detection and recognition algorithm. There we have used basically first we have to take the video feed, then we have to separate, isolate the object, classify the different object, because there may be pedestrian, there may be some trees, buildings or road signage. So we have to first isolate the object, and relevant object, whatever the relevant object is there, we have to connect those relevant objects, because let us suppose 2 moving cars are there. So these moving cursor related relevant objects. So we have to connect those two relevant objects, that two moving curves, and according to that we have to generate the scene. Okay, and accordingly we have to plan and take the action. So therefore these are the major thing that we have to do, and we have used different machine learning algorithms. CNN, basically we have used CNN algorithm. I'll show you in details. We have used deep learning DQL algorithm. It is basically a subset of deep reinforcement learning, this deep Q learning algorithm. And also we have used a combined CNN algorithm to perceive the state of environment in which the agent find itself, and deep Q network to act on perceived environment. And a driving agent of software program is there to learn and follow the lanes and avoid randomly placed obstacle in the simulation. And another agent we have to apply. We have used here in next few slides. I'll show that we have taken LISA data set and used RCNN, faster RCNN algorithm applied there, and the test results was super. It shows 92% accuracy result. So in the next few slides, I'll show you that. So integrated and integration of supervised learning and reinforcement learning is required, because in the first two steps, basically perception and scene generations, are these two steps are performed with supervised learning. First, the program is trained using a large number of digital photographs involving the driving scene. Because the driving scene are taken captured through video camera, and what we have to do, we have to break those video camera feed to images, and then we have to classify those images using supervised learning. So after classifications of those images, we have to isolate the different objects, and accordingly we have to take care. So we have used different algorithm. I'll show you the algorithm for detecting object, for detecting traffic lanes, for detecting traffic lights, for detecting lanes. So for all of these different learning process, learning algorithm we have used here. So basically reinforcement learning we have used here, because it is this reinforcement kind of learning basically used in obstacle avoidance of robot, the bipedal robot that we are using. That is this reinforcement learning is basically used there to avoid the collisions, to avoid the accident. And here also the same algorithm we have used reinforcement learning as well as deep Q learning to make a simulated environment. Okay, so here we can see the driving algorithm. So driving functions are basically divided into three major categories. What are those three major categories? The fundamental of these fundamental of driving functions, then these warning system and hazard detection. You can see these fundamental of driving function, warning system and hazard detection. So what is this fundamental of driving function? This fundamental of driving function is basically includes like white lane detection, traffic signal recognition, and traffic sign recognition, and lane-less driving. Okay, so you have the scope of research in these three areas, and we have done research on both these three areas. So you can do research on these fundamental of driving functions, because these white lane detections are most important. Traffic sign recognition also most important. Otherwise, you can collide And you can also have to work on laneless driving, because there are some lanes where white lines are not available. So what you should do there? How you can drive? So these you have a lot of scope on this area, fundamental of driving function. Then warning system. Warning system is what that driver monitoring, because there may be some hazard like pedestrian. Suddenly a pedestrian come across your car. So these hazard detection. Then there may be some sidewalk cyclist are there. So that you have to also detect. Okay. So that basically it is for emergency purpose, right? Because it is in normally in normal road, pedestrian should not cross across your vehicle. If you are if you are going in a green light, green traffic light, so pedestrian should not come across your road. However, however, it is not a 100%. You cannot say ki the movement of pedestrian should not be here. So therefore a pedestrian may come across your, so this is an emergency purpose. May a cyclist come across your come across your path. So that is an emergency situation. So these emergency situations should be tackled by some warning system, right? So you can also work on this warning system. And third is hazard detection. Hazard detection is like obstacle detection, is collision detection, and risk level estimations. So obstacle detections means there may be some tree, some lamppost, some building or something there. So you have to detect the obstacle. Collision detection, you have to continuously monitor the movement of your previous vehicle, and accordingly you can make the distance between these two vehicles. So collision. So therefore, so this way you can detect the collision. And also risk level estimation. So risk level estimation is like you have to detect the movement of moving car. You have to detect the movement of pedestrian. Let us suppose the pedestrian is moving, and it is projecting towards your path. Okay, so that is called hazard detection. So you have a lot of work scope on hazard detection also. So therefore, three major categories are there: these fundamental driving function, warning system, and hazard detection. And we have worked on both of these three categories. And though there is lots of scope doing research on all of these three categories, and it is not like that you have to work on the fundamental functions like all of these categories: wildlife detection, traffic signal, traffic recognition, laneless driving. Not like that. This in the laneless driving only, in the laneless driving topic, there are thousands of papers, thousands of researchers who are working on, especially on the laneless driving, or especially on the white lane recognitions, right? So each of these categories, each of these topics, there is a huge scope of research, because till date you cannot we cannot find 100% accuracy. So therefore a lot of research are going on, and you have a lot of scope of research in these areas. So here we have worked on the white lane detections. So how white lane can be detected? So so you can see here the segmentation is you have to use the segmentation technique to detect the white lane that painted on the so white lane for need to search through different data sets that are available in over the internet. And data sets there we have used VGGNet here for training of the white lane data set, as well as to test. You can see in this figure, these white lanes are correctly, more or less accurately detected. In these first in this segmentation, you can see these picture. The white lanes are detected, almost accurately detected, and using these scene generation, they have then we have made this scene generation. Okay, and according to the white lane, you can plan your vehicle, means path planning of your vehicle. Next, coming into the signal, you can say, though there are, there are three signals only, red, green, and amber. However, there are other signals are available, like go left, go right, or stop left, or warning left. So therefore, for this signal, there very good data sets are available in the internet, that is called LISA data set. So these LISA data set are freely available over the internet. We have taken these LISA data set of various traffic, traffic signals. So these are the data set, 6 classes of traffic light data set we have taken from the LISA data set. We have what we have used. We have used convolution algorithm, RCNN algorithm here, to first we feature the map, then we have classify these object. Okay, so there we have got a precision around 43.5%. Precision of these. Another Pascal VOC dataset. It was taken from 2010 dataset, and in the LISA dataset, we have find around 92% accuracy there. So because there are a lot of noises are there, there may be some clarity issue, some ear clarity issues are there. So due to that, till date we have not find, means in the literature also not found 100% accuracy in this traffic signal detection. Then comes into the traffic sign. There are traffic signs are there, different traffic sign like stop, or the maximum speed limits are maybe there. So that has to be accurately detected. It comes under the perception detection, right? So there also we have used and the same algorithm, RCNN algorithm, and you can see the result is around 85%. In some cases we have found 99% even accuracy. Okay, so and these also clearly, these stop signage has been clearly detected through our algorithm. Right. So this is the results of these traffic signal recognitions. So we have we have trained with all real life image data set, and we have used there a German traffic sign data set containing more than 50,000 images, and which belongs to 45 classes, and another Belgium traffic data set that includes 7,000 single images, and that divided into 62 classes. And the test results are like these. We can see these we have accurately found around 92%, go left 62%, stop 96%, and some warnings is warning as 99% of accuracy. So this is a good result. We have found these traffic signal recognition. Then coming to these lane-less driving, another important thing, because in some of the roads, in villages, village road specifically, in urban areas, wide lanes are there, but in village areas there is no remarkable, wide lanes are there. So therefore, without mark, how you can drive your car, means how to identify the pavements, right? So therefore, there may be road without pavement also. Okay, so you can see these two figure A paved road without lanes, and figure B unpaved road. Okay, these are the totally village roads. So therefore, how to go through this road with autonomous vehicle? Okay, so here also we have used or RCNN algorithm, and we have segmented these like these figure C and figure D. You can see the segmented path road from which you can plan and take actions accordingly. Next, coming into the yes, Professor Meera will conclude within 5 minutes. So next is YOLO and detection objects. So YOLO algorithm is most popular algorithm. You'll find most of the researchers are working on YOLO algorithm. That is, you only look once. So we have also used YOLO algorithm to find the hazards, to find the different objects and classify those different objects. And it is a very a popular algorithm, and it is very accurate algorithm. Most of the researchers are working on this algorithm, and you can find in any picture it will accurately detect the bus, different objects. Like here we have detected bus, person, human being, that means pedestrian, that we have detected. And it has, you can see these an open image data set. They have more than 15 million data sets. Okay. So therefore you'll accurately detect the different hazards, different objects, not only in this area, in other areas also. You can find, you can detect different objects like ball, pen, pencil, smartphone, any kind of object you can detect through this YOLO algorithm, right? This is the collision avoidance algorithm. So collision avoidance basically there are 4 type of collisions. So sorry, 2 type of collision obstacle that we have to avoid. First one is these obstacle can be, means it is a moving obstacle. So it is a moving obstacle. So therefore you first need to close to the obstacle, then you have to avoid the obstacle. Or it is a without means it is a non-movement obstacle. So you can directly avoid these obstacle through this. Okay. So other than this, there are also let us suppose 2 other vehicles are coming to you, and these has some distances. So that you have to calculate whether it is in low risk, within low risk category or high risk category. That um, you have to customize your algorithm, and you have to prioritize the risk zone. Okay, so that you have to calculate as per your vehicle size and the distance. So that you have to calculate accordingly whether it is comes under within 4 feet of distance of your vehicle. So it should be in the high risk. If it is the distance more than 4 feet of your vehicle, then it will be in the low risk zone. So accordingly you can take the actions. So here estimations of the self-driving, these whatever I have discussed, do not have much time to explain all these. So different, you have to also not only the distance, you have to take the, you have to prioritize the object also, like human, cars, motorbike, animals, which are the, these are the high priority, because human, pedestrian is the high priority, these. However, some other things like some animals, some things, those are the low priorities, right? So therefore these things, these priority distance and high priority distance and low high priority means, you can divide it like this. We have made 4 rules. Rule number 1: if the priority is low and the distance is far, then it is called risk level 1. And if the priority is high, the distance is far, is called risk level 5. And if the priority is low, distance is close, it is called risk level 6. And if the priority is high as well as distance is close, it is called risk level 10. Means it is in the highly risk, right? So according to this rule, you can use various algorithms of customize your algorithm, and you have to calculate the result, and accordingly you have to plan your driving, right? So these things also you can work on these things, estimations of risk level for self-driving. A lot of research work are going in this particular topic. So we have also worked on this, and this is another area of research on autonomous vehicle, that is called warning system. So warning system, like you can see pedestrian warning system. This is hazardous level less than 1. You can see there is no pedestrian. So only a lamppost is there. So though this lamppost has hazardous, is hazardous. So hazardous level less than 1. But here also you can see in the image B also some hazard is there. Some moving vehicles are there. However, the hazardous level is very low because the traffics are moving. Here you can see this pedestrian are moving. So these pictures see the hazardous level is very high because this pedestrian is approaching towards the middle of the road where you are moving, right? So these hazard you have to perfectly identify, and accordingly warning system should be there. Okay, and you can see in the next picture, this pedestrian hazard level is less than this picture because pedestrian is moving towards the end of the road, right? So there is very little chance to collide until he stops there, right? So these things also you can do research on this particular thing, these hazardous thing, and also another research area of work is driver monitoring system of detecting drowsiness. If it is basically detecting your eyelid, whether it is open or closed. If it is closed, it will warn you you are drowsy, right? So these things are already been applied in semi-autonomous vehicles like this. Okay. So here we have used sidewalk cyclist detection. It is also another hazard. You have to detect a cyclist, and it detects to different side cameras, and we can use deep convolution generative adversarial network, that is GN network, or DCGA network to predict the future position of the cyclist, right? So this is using GAN. Also you can work on this area. Here the deep the enforcement learning, how we have used what are the the equation that we have used here, the learning rate and discount factor. And this is the DeepQ network. So I do not have much time to explain these. So you can find these into our book. If you go through our book, these things have whatever the equations and whatever the data set we have used are available there. And this is the experimental results of our DeepQ network of Struckel and agent. You can see there, and this is a verification of robot car using a MicroPython board. So that we have used in our labs. And finally, another scope of research area that will explain. I'll explain within a minute. That Lift 3D object detection for autonomous vehicle. That is basically 3D object detection, and we have used 3 algorithms. UNet algorithm, you can see these network architecture of UNet algorithm. This is U type of algorithm. We have used YOLO algorithm there, the same algorithm we have used earlier, and also we have used VoxelNet algorithm there. Okay, and this is the evaluation matrix that has been performed, and this is the results. You can see the obstacle pedestrian that has been detected more or less accurately, and this is the final test results, and accuracy is shown here. It is around 60 to 90% accuracy. And here we have detected some of the flying object. Means some of the flying birds or things can come under your vehicle. So therefore, the flying object can also be detected. This is also another area of research that we can explore. So that has been classified, and accordingly you can take. Okay, so motion-based method as well as hybrid method we have used to detect the 3D flying object here, and this is the methodology we have used here. Basically, convolution network we have used different matrix 1 by 1, 2 by 2, 5 by 5, and 3 by 3 convolution matrix we have used here, and this is the result. You can see various flying object can be detected accurately. Though these left side objects are not important for your autonomous vehicle, however, these flying objects like birds may come under your vehicle area. So therefore, that is the reason we have explored these areas. Right. So this is a sample Google vehicle, Google car. You can find these over the net. So I'm not going to explain these. These are the sensors and cameras to generate the scenes and take the actions. Right. Now, finally, we are going to see the advantages and disadvantages of the limitations of these, autonomous vehicle. So advantages, it's like we can manage the traffic flow better. We can relieve the vehicles. We can avoid the accidents. We can increase the roadway capacity and determine the current locations. So these are the advantages of these autonomous vehicle, and some limitations are also there, like vehicle can be switched off on the road. Maybe some software issues are there. Maybe some sensor can stop or malfunctions, right? Also, it has less security when using internet, because someone can hack, and so hacker can change the route in case of failure sensor. The vehicle can create a chance of accident. In the rainfall also, it is difficult to detect the signal accurately. So So therefore, sorry. This is the reference that we have taken all these work through from our 3 books that we have already shared with you. So for any queries or questions also you can contact through me through email. My email is given there. So any questions or queries you can ask.
Okay, thank you very much, Professor Gus Ankus, for the very interesting presentation. Now we have a question here from Ms. Desi Novita. According your research and your experience, what are the important parameters that you applied on your AI autonomous car in real time? We know that so many sensors, communication, and non-linear environment are there. Yeah.
According to research and experiment, what are the important parameters that you have applied? Basically, we have applied. We have worked on perception and scene generation, and as we have said, four major things are very important for to run an autonomous vehicle. That is the collisions avoidance, collision perception and scene generation are most important. And for these, the most important thing is to detect the object accurately. Because if you cannot detect the object, like it is a moving vehicle or stopped vehicle, you'll collide. And most of the accident happens because some of the vehicle stops on the road, right, roadside or in the middle of the road. If you cannot identify whether it is moving or stop, so you'll collide, right? So therefore, the most important thing is to detect the object and to detect the motion accurately.
Okay, thank you very much for your answer. I think it's enough for the session. Oh, wait. We have one question from Mr. Muhammad Zidan. Deep learning and big data need a high processing computer. What is the key for us, although we don't have a HPC system, especially in your case too?
Not really. You can use any computer with i5 or i3 or better. Even in i3 computer with 8 GB RAM, you can perform these work. Mainly all these work we have done on Python. So you can run these deep learning algorithm using Python in any Pentium i3 computer with minimum 8 GB RAM.
Okay. Yep. Thank you very much for answer and the experience, Professor Ankus. I'm sorry for Akira Reka because the time is up. So if you want to ask more, and I'm sorry, Dio, it's very interesting session, but we have to stop because we have another parallel session. Maybe you can ask directly with email to Professor Ankus. Okay, with the end of this Q&A session, our session will also end this time. Once again, thank you very much for Professor Ankus and Professor Wan Muhammad Amir for joining us in ICAI BDA 2021. Thank you also to all participants who actively participate in this session. I apologize if there's a shortcoming in moderating this session. I return the event to the MC for the awarding of the certification.
Thank you very much, Professor Mira.
Okay, thank you, Mrs. Mira. Up next, we are going to have another certificate of appreciation presentation, which will be presented by me as the master of ceremony of today's event to the speaker, Associate Professor Ankus Ghosh of the Nausea University, India. I'm sorry if I pronounced that wrong, but I would like to invite you to join me here, and I think the operators can spotlight him and share screen the certificate. Okay, to the documentation team. You may lead the photo session.
Thank you very much.
Okay, next we have another certificate of appreciation for our third moderator of the day.
Thank you,
it is-
Professor Linda, also.
Okay, this one is for Mrs. Mira. Thank you for being our moderator today. And I would like to ask the operator to spotlight Mrs. Mira and share screen the certificate.
Thank you very much, Brilliant.
You're welcome, Mrs. Mira. Also, you're welcome, Professor Anquist. Is it done? Documentation team. Okay. Okay. Once again, we would like to thank our sponsors, namely DigiTicket, PhiloIt, Cityscope, Dewa Web, Cakap, Jagel, Bandung Digital Valley, Dilo, Codepolitan, Dialit, and finally Kolaborasi. This event is organized by Research Center of Artificial Intelligence and Big Data UNPAD, or AIDA, co-organized by Fakultas MIPA UNPAD and Himatif FMIPA UNPAD, sponsored by IEEE, Comsoc, and Universitas Padjadjaran. Now, before we proceed to attendance, form filling, and parallel session, I would like to encourage all of you to turn on your camera because we will have a documentation photo session. Also, maybe the operators can remove the spotlight from me so we can see everyone. Once again, I would like to ask all of the attendants to open their camera as we are going to have a photo session together. Okay, to the documentation team, you may lead the photo session. Okay, I think I'm going to count it down by myself. Okay, once again, I'm waiting for you all to open your camera because I will start the countdown in, okay, maybe now. Okay, 3, 2, 1. Okay, maybe once more. Okay, 3, 2, 1. Okay, do you get it, operator and documentation team? Okay, up next, we are the team. We would like to all participants to please fill the attendance form on the chat box. I will send it now. Before we go into the next session. Okay, I would like to ask all of the participants in the Zoom meeting to fill out both of them, and then we can start the next session. Okay. Okay, I think, okay, while you are filling the form, I just want to say that we have come to the last session, and I would like to inform that after this, we will proceed to the parallel session in breakout rooms for the presenters. Participants are allowed to join, so feel free to join the breakout rooms. It will start at 3 p.m. So please wait as you will be directed to join the breakout rooms. Before that, I would like to ask you to rename your Zoom meeting name to coderoom _ name, for example. Coderoom. Okay, I think that is all from me. On behalf of the community, I would like to thank you for the participation, and I would like to apologize if there are any shortcomings in the implementation of today's session. And I think that's all for me. My name is Brilliant Dimas Akbareza Purwadi. Don't forget to keep following health protocols, and see you tomorrow on oh my God, I'm sorry. See you tomorrow on the day 3 of International Conference of analytics and big data. Analytics and big data. Oh my God, I forgot. Okay. Okay, a little bit nervous here. I'm sorry, because it's already afternoon. Once again, don't forget to keep following the health protocols, and see you tomorrow on ICA IBDA 2021 Day 3. Good afternoon and have a great day, and I'm sorry for all the shortcomings. Thank you.
Thank you, Brilliant. Thank you, Prof. Ankus, Prof. Wan Muhammad Amir.
Thank you, Prof. Amir, Prof. Ankus.
Yeah, thank you, thank you. Thank you,
Thank
Helena.
you.
Okay, thank you to Fahri, to Bu Intan. May I leave the Zoom meeting now? For the operator. Okay, thank you semuanya. I'm sorry if there are any thoughts coming and ada kesalahan dalam berbicara. Saya Brilliant Dimas Brody. Terima kasih. Thank you for the opportunity. I hope I can see you all again in the future. Dah, thank you.
Thank you, Brilliant.
Thank you, Brilliant.
Terima kasih, Ibu. Terima kasih sama-sama, Ibu. Oke, dah.